Hi there, today we're working on creating a full FPS weapon manager from a basic 3D scene all the way up to a fully customizable weapon system that will allow you to add as many weapons as you like, all the hit scan and projectile weapons you can possibly think of. We'll even add a melee attack at the end there too. Then you can even go on to make a full FPS game like I am. I have a prototype here which is kind of like traveling between dimensions, I guess, like that one level in Titanfall, I think. It's very early days. This is the first part in an incredibly long tutorial series that I'm doing that will allow you to make a full FPS weapon manager, which will be everything from what we're doing today all the way up until adding the juice and all the good stuff that makes it look like a legit FPS game that you might find in Steam. I thought I would edit together part 1 for newcomers to make the experience a little bit better. There are a couple of jumps between the subjects because I did not film this all in one go. If this is helpful for you, please like and subscribe. It really helps the channel out. Keep an eye out for that second part in a few months' time where we start to add some juice to this project. Let's get started. If you haven't created a project already, just start one up. So let's just jump into it. I'm going to open up mine. It's going to look a bit different because I've already created the world, but I don't have an FPS controller in here. So let's start. The first thing we need to do is create a character body 3D. They've changed the name on me. I find it hard to find it. We just need a collision shape 3D as well, and a camera. And I'm going to go ahead and just make sure that's just a child of the main character body 3D. And I'm just going to rename this to main camera. Give this a collision shape. It can be anything you want, but capsule is typical. I like to just change the shape to a typical height rather than 2 meters. And let's just bring this up so it's in the scene. And the other thing I like to do is also raise the camera up so it would be at some kind of height level. All right, let's just push this guy back a bit. So we're going to add a script just like that. And the magic in Godot 4 is this template. I don't know if they had them in Godot 3, maybe in the later ones. I'm not too sure, but these templates are magic. So I'm going to click create, and right away you've got pretty much everything you need if you run this game. You guys probably already know this. Godot 4 has been out for a while now. We've got everything we need for movement and jumping. We just don't have that mouse movement. So I'm going to show you guys how to put that in today. So the very first thing that we want to do is get access to that main camera node. Now I'm going to access it as a unique name because this is very basic, and I'm sort of just assuming that we're going to probably change things as this project gets more complicated. So I'm going to call this main camera, get node, brackets, string, percentage, and then main camera. Okay, that's done. Okay, we need 2 variables to make this work. We're going to need to create a variable called camera rotation. And this is just going to be a vector 2, and I'm just going to initialize it as 0, 0. Okay, and then we also need a variable called mouse sensitivity. I don't know if I'm spelling that right. Feel free to look it up and correct me in the comments. 0.1, it's a small number because we're working in radians, so you know we don't need much to do a full circle. I think it's just around 3. So we just want to make that number way smaller. You can always expose this setting later as your project grows so that your users can edit it and make it either more or less sensitive depending on their mouse. So then I'm just going to add a ready function here. We're not going to do much with this. Once again, keeping it simple. So we're going to go input.set mouse mode, and we're just going to turn it mouse mode captured, so that'll just make it so the mouse doesn't show on the screen as we work through this. Okay, and the rest is all in the input function. Okay, so the rest of this is happening in the input function. I'm just going to add in a quick little check to see if we press the escape key and basically expose the mouse if we do that. It just makes it easier to debug. We can always make this more complicated as time goes on, like I keep saying. And okay, so we've got that there. Okay, this is where the magic happens. We've got if event is input event mouse motion. We're going to create a variable and we're going to call it mouse event. We're going to set it equal to event.relative multiplied by mouse sensitivity, which is what we set up there. And then we're going to call a function called camera look, and we're going to pass in that event. Okay, so let's create this function, camera look, and I'm just going to call the variable movement, and it's a vector 2. Okay, so what we do here is essentially we add our movement to the camera rotation variable. So this would be plus equals movement. Okay, then there's two functions we need to call. Transform dot basis equals basis, and main camera dot transform dot basis equals basis. This is what makes it possible, and I've spelled transform wrong. That's okay. And then there's two other functions we need to call, which is really the magic. Rotate object local, and first we always rotate in Y, so vector 3, this is what this expects. You have to tell it what vector you want to rotate, so this is vector 3, 0, 1, 0. There are other ways to define that variable. This is just what I like to do. And it's negative camera rotation dot X. And that's that. I'll make a note here just in case you're playing around with this and you forget. First, rotate 6Y. Then you want to rotate the main camera instead of the kinematic body. Rotate. Actually, I might just copy because I can barely see my keyboard. Rotate object local. And it's vector 3 again. 0. Oh, sorry. 1. 0, 0. So we're doing the X rotation next, and we'll call negative camera rotation dot Y, and we'll go then rotate X. Okay, so the other thing we might also want to do is just clamp the rotation of the Y axis. So I'm going to call camera rotation dot Y equals clamp camera rotation dot Y negative 1.5 comma 1.2, because we are working in radians again, so it's not going to be degrees. You could convert these if you wanted to, but it's easier just to directly key them in here. Okay, so this is it. Looks like I forgot a comma there. That's okay. Let's go again. Okay, now we're working perfectly. Now, the one thing you'll notice is that no matter where I turn my mouse, I'm always going forward. I'm pressing W, I should say right now. I'm always moving forward. Now, to me, this is pure magic, because back in Godot 3.5, this was a little bit more complicated to implement. But if you look down in this automatic script, they've got transform basis times vector 3 input directions. And this is what makes it work. It's why I'm rotating the kinematic body here and not the main camera. Now, if you rotate the character, it'll actually get that direction automatically, just on the basis of how this is set up. So it's super easy. I don't know how long we've been recording for. This has been, it says 15 minutes on my screen, but by the time I cut this up, it's going to be even shorter. So that is all you need to do. This is complicated, to say the least. Why do we need to do transform basis equals basis? We're basically resetting the basis every time that we do a rotation. All these kind of things, they're very confusing. If you need to understand more, or if you want to know how rotation really works, you can come to the docs and read about using 3D transforms as a whole thing. This is how I had to do it when I was working it out, last year or the year before in Godot 3. And here is basically the snippet that they give you for an FPS style controller, which is pretty similar to what I've given you here, except for the rotation for the main camera in the Y. Hey guys, Isaac from the future here. I noticed that I missed explaining this function in my tutorial, and I thought it was worth coming back and explaining. Just sort of what we're doing here. We're taking the input event mouse motion, so that's just a number on your screen, event.relative. So if you printed that out, it would just essentially be a coordinate that relates to the direction that your mouse is moving at any given time. And we can basically use this information. We pass it on to camera look, and we add that to the camera rotation, and that just accumulates indefinitely. Obviously, we clamp the Y because we don't want to be able to spin around forever, but if we are turning on the Y-axis, then we want to be able to just spin forever. And then we come down to the rotate object local. Now first we're going to do it in the Y, but you might notice that we're using camera rotation.x. So if you think about that, with your mouse, you're just moving it leftways across the screen, and that's actually the x-axis for your screen, but we want to spin on the Y. If you imagine like a pin going through your character's head, Y is the one that goes at the top, and we're just turning that on its head. And then next we're going to rotate in the X, and we're going to use the Y. So that's actually the same principle. When we push upwards on our screen, then that's actually the Y-axis on our screen, but it's the X-axis for our character. If you imagine just you've got your 3D gimbal, X goes through the character and we're rotating that. So that's your up and down. And that's sort of just a slight overview of how that works. And I thought that might be a bit nicer than just skipping that altogether.
First thing that I'm actually going to do is just add an environment to the scene because it looks pretty boring in the last tutorial. So I'm going to click these three little dots and just click add environment to scene. It's just an overcast looking kind of environment, nothing too special, but it will just make things look a little bit nicer while we're here. Okay, so the next thing I want to do is just click this character body 3D and save branch as scene. I'm going to save that in the tutorial folder, and I'm just going to call it something like FPS character probably. Okay, so now I've done that, I'm going to open that scene and we're going to reset the transforms since we set this up in another scene. So things are a bit wonky here. So I'll just click the character and come down to transform. Just click this little round refresh looking button. And there we go. Okay, so I'm going to rename this as well, something like FPS character, the same as the scene name. Nice and easy. And I'll just come back over into the world and I'll probably delete this because, I don't know, it doesn't rename it for you and I don't like that. So just drop this in and I'll just move it back over to roughly where it was, make sure it's in the scene. Okay. Now we can jump back over here and start workings. Okay, so the first thing I want to do is just split the view in two so that we can start setting up our animations. I'm going to come down to this bottom one and I'm going to click preview on the camera so that when we're doing our animations, we can see what we're doing. I'm going to add a node here. We want to look for a node 3D, just a plain old node 3D. And I'm just going to rename that to weapons_manager. We'll add another child to that. It'll be another node 3D. And I'll probably just call this FPS underscore rig. This is where we'll put the actual weapon models and animate them. So I've got some models from Kenny. He's got all the good stuff. So I'll link his website down below. If you need some, you can just drag some in. Doesn't really matter for this demonstration. I'll look for a pistol and sort of like an automatic rifle as well. And one other one just for good measure as well. This one will do. All right, so they're just sitting right in the middle of our scene. So we'll just want to select them all and just push them down to the feet where they're out of view of the camera. And now we need to add an animation player. So I'll hit add node again and click on animation player. So blaster N activate is the first one. I'm going to key in the position they're at now as the starting position of the activate. And I'm going to make them all invisible as well. And toggle that visibility on as I start to key in this animation. And I'll just bring that up to where I think it should be and key that in. Cool, I'll make it a bit shorter, looks all right. Sometimes you've just got to play around with these till you get something that you like. I want it to be a bit quicker, but I noticed that it was spinning around like crazy, so I just had to fiddle around with the exact point. And I kind of liked the spin into view, so I ended up putting that back in after I fixed it. So the key thing to remember here is that your starting frames for the deactivate should be the same as the ending frames for the activate animation. So I'll just key them in and then I'll just push everything back to where it was. As long as it's out of sight and not visible on the model, then you should be good. We don't want to draw in a shadow when it's not active, so just make sure to click that visibility off as it descends and we'll key that in. Just check out your animations as you go, just make sure you're happy with them. Okay, so on to the next shoot, probably the most important animation that you're going to do. So just make sure you pay attention to everything. I think it's best as if the gun moves backwards first and then rotates upwards. Just looks a little bit more believable. So I'll just key these in and things will start to look pretty good. And you really don't need as much time as you think you do, even for a longer shoot animation. 0.2 seconds is quite a long time. And the other key thing to remember is I'm going to be using the animation player as a way of regulating our fire rate. Other people will do this differently and that's fine, but make sure that you're setting your track length to be the same as the ending point of your animation. You don't want any lingering time unless, of course you do, but just make sure that you're cognizant of the fact that the track time, which is up in the top right-hand corner, is the same as what you want the fire rate to be. I feel like it's mandatory in every single indie game where there's no actual rig, there's just floating guns. You have to spin the weapon in order to reload. If you don't do this, then you're not a true indie FPS developer. So that's what we'll do here. Okay, so the next one is the out of ammo. This is what's going to play when the gun runs out of ammo and they can't reload anymore. We're just going to make it rock back and forth. Just nice and simple so they can see that it's actually not firing. I'm not going to put any sound in this. I think in a previous tutorial for Godot 3.5 I added sound and particle effects. We're not going that in depth, so I'm just going to make this shake just so it's nice and visually clear that we're not reloading. Okay, so those are the 5 animations I want for each of my guns. I'm just going to blast through now and set this up on the next 2 weapons. I'm going to speed this up so you don't have to watch me, and I'll see you when we are setting up the resource to manage all of this. Okay, so that's all set up now. I'm going to close off all these folders so it's a little bit more readable, and I will create a resource. So I'm going to right click here and I'm going to add a script. So I'm going to come down to new and script. We're not going to add this to any nodes, so that's how we're going to have to do it. Well, I'm going to call this one weapon underscore resource. And where it says extends node, I'm going to delete that and replace it with resource. And class underscore name so that we can find it easy. I'm going to call mine weapons resource, and I'm spelling it wrong, so I'm going to come back here and correct that. Okay, so let's add a couple of variables. In fact, a resource is generally just a lot of export variables, and it can hold functions, but ours are just going to be variables. So the first one is obviously the weapon name as a string, and the list of the 5 animations that we set up. So I'm just going to call them the name of the animation underscore anim. feel free to either copy that or do your own thing. I don't really feel like writing animation out. It's a lot of letters. So reload underscore anim, and these are all strings, by the way. So we'll do the export here, not change. Make sure that you try to make these as close to what you actually named your animations as possible. Otherwise, things can get a little bit confusing when you do have a lot of animations going. Obviously, there are arguments for using different ways of keeping track of all this data. You could use a JSON file, you could use a CSV file. Depends on how many weapons are in your game and the number of different actions that are available. So we're keeping this simple with the resource. It's nice and easy to set up that way. The other set of variables that we need are obviously the ammo. The current ammo is the amount that you can shoot. The reserve ammo is the amount that you can reload from, and I like to call it magazine. This is the amount that you can reload when you press the reload button, the maximum amount you can. And the max ammo is the maximum amount that you can have in reserve. Okay, so, and I'll also just add an auto fire variable as well, auto underscore fire as a Boolean. Okay, those are all the variables that we need right now. We're going to add to this as we go along, but this will do for now. I'm also going to come down and create a folder called Weapon Resources. And in that folder, I'm just going to right click, new resource, come down and look for weapon resource in the list. Weapon resource. So you'll see I've got an old one there. That's because I've been working on this a couple times. Okay, so I'm just going to name these the exact same as the actual weapon models, just so that I know what they are, nice and easy to keep track of. And you'll see we've got our first setup here. We've all got these variables up here. I'm just going to type them in, the name of the weapon, Blaster N. I'll copy that and I'll just come down. Now, the most important thing is when you're putting in these animations, make sure that they absolutely match the name of the animation. I almost put an underscore in there. I don't need it. There's a space. So they have to match exactly your animations. If you're having trouble with this later on and the animations aren't playing, it could be because there's a name wrong. You'll get an error in the debugger, but it won't actually crash the game. So double check that if you're having problems. And then just set up your weapon for the ammo that you want, making sure that I've got all my animations checked. And so yeah, just, whatever weapon you're making, set the current ammo, the reserve ammo, the magazine. I said before, that's the maximum amount you can reload, and the max ammo is the amount that you can hold in reserve, the maximum amount you can hold in reserve. So those are the variable names that I'm using. Hopefully that makes sense. I'm going to go through and create the rest of these resources. I'll speed through this section so you guys don't have to watch me just make these. Okay, now that we have them, we can start actually setting up our weapon manager. This is where the magic happens, all right? So we'll add a script to the weapons manager. It can be called weapons manager, that's fine. It extends node 3D, that is absolutely fine as well. Okay, so we need a few variables to make this work. The first thing we want to do is get our animation player. So I'll right click access to unique name on animation player, and I'll hit that at onReady var animation underscore player, and I'll write get underscore node and quotation marks, and then just drag the node over to that. And the next variable we need is the current weapon. This is the variable that we're making all the calls on. And the next variable will be the weapon stack, which is just going to be an array of all the weapons that we currently have available to us in the game. So if you pick up a weapon, it gets put in the stack. Okay, so we've got weapon indicator. That's just going to be a variable to keep track of the array. Next, we've got next weapon, which will be a string that we hold when we're changing weapons. All right, so now we've got weapon list, which is going to be a dictionary that we can use to keep track of all the weapons available in the entire game, even if we're not holding them. And we're going to have an export variable as well, which will be the resources. I'm just going to name mine underscore weapon resources, and it's going to be an array. And this is the trick, square brackets, and then type weapon resource in there. And it'll just allow us to drag those weapon resources into the array, which is nice and convenient. And then export variable start weapons, which is just going to be an array of all the weapons that are available at the start of the game or when you load it up. Okay, so here we can start setting it up. I'll add 3 items to the array and just drag these resources over. You can just drop them in. Doesn't really matter the order. Okay, and then we'll come back up and I'll click on that again and I'll add 2 starting weapons. I won't do all 3 because I'll save one to show how to pick up a weapon in a later tutorial. But right now I want to show you guys how to change weapons. So we'll start with that. I'll add in Blaster D and Blaster N, I think. Okay, so just make sure that everything's lined up and you're happy with it. And we'll start setting up the rest of the script. All right, so we're going to need a couple of functions. I'm going to type these out now. First, we want initialize. And then we're going to need an enter. And I'm just going to write pass, and we'll explain these in a second. Next, we're going to need change underscore weapon, which will be the main one to change weapons, and an exit as well. And that'll be when we're exiting the weapon. And I think I'll just put change weapon at the bottom of this script. Okay. We're going to need a ready as well. And we're just going to call initialize. It'll be the first thing we call. It's how we enter in to our state machine, because that's essentially what this is. A state machine which controls the current weapon state that we're in. Okay, so the exit is going to be what we call before we change weapons to sort of validate that we're not in the middle of something else or whatever it is. Anything that you need to validate. And enter is going to be what we call when we enter into the next weapon. So we can, play the right animation. We can reset some variables if we need to, update the ammo in the HUD or whatever it is. All right, so for our initialize, we are going to want to pass in the starting weapons. And obviously it's going to error out under the ready. That's going to be an array. We'll pass in the export variable start weapons and we can get started. So the first thing that we want to do is actually create our dictionary list of all the weapons that are in the game. So to quickly explain, the weapon resources array that we have set up above isn't really going to be used except to build this dictionary. We could just have a dictionary and skip the array altogether, but we want to loop through for weapon in weapon resources, weapon list, and then we'll go brackets weapon dot weapon underscore name, and we'll set that equal to the weapon. Okay, and that'll create our dictionary so that as we're going through this, we can refer to it. Okay, the next thing we want to do is just loop through our start weapons. So for I in start weapons, weapon underscore stack dot pushback I. So we're just going to push all the start weapons into our array. So our weapon stack is just going to be a string reference to each weapon that we can, call up with that dictionary. Alrighty. So we want to set the current weapon equal to the weapons list, square brackets weapon stack, square brackets 0. So that'll just be the first weapon in the stack. This is going to be the very first weapon that we pull up. And then I'm going to call enter. Okay, so there's not a lot for us to do right now when we call enter. All I can really think to do is just play that first animation. So I'm going to call the animation player.q, and I'm just going to pass in current weapon.activate anim. And once again, just a reminder to make sure that you've got the variable name right and you've also got the animation name right. Because I found with this way of referring to things, it's not going to, pre-fill in the variables or anything like that. So it's not going to tell you it's wrong until you run the game. So I'm going to run the game here and I can tell that I've got it right because the weapon has shown up and is playing. Okay, let's move on. And we actually, in order to change weapons, we're going to need to set up some inputs. So I'm going to come up to the project settings and I'm going to add some actions here. So we're going to call it weapon underscore up. And we're going to add that. And I'll weapon underscore down. And I'm going to make these up and down on my keyboard just because my mouse is a little bit broken at the moment. Okay, so, and I'm also going to add shoot and reload. I'm going to set them shoot to left mouse button, and I'll come back up here and I'll add reload as well. And I'll set that to R. Okay, so now that we've got that, we can add the input function to our script. So I'll come up below the ready and I'll just enter down a bit and I'll type func_input event, and we can do a check if event.isActionPressed weapon up, and we'll just pull up our weapon indicator and we'll increment that. I'm going to use the min function, so I'll choose between the smaller of the two, weapon indicator +1, or the weapon stack.size -1. So we don't want to go greater than the length of the array. That's why I'm doing it this way. And then I'll just call exit. And I'll need to pass in the weapon stack square brackets weapon indicator. Okay. And we're going to get a bit of an error here because exit doesn't have a variable, too many arguments. So make sure to come down here where it says exit and just add underscore next weapon, and we'll say that that's a string so we don't make any mistakes. Okay, so I'm going to add the exact same thing for weapon down. So if event.isActionPressed weapon down, I'm going to set weapon indicator, and this time I'm going to use max. So it's either going to be weapon indicator -1 or 0. So we can't go below 0. And then I'll call exit again, and I'll pass in the exact same thing. So I'm just going to copy this above and paste that in. Okay, so now in our exit, we can start working on this. So I'll just delete the pass and I'll check if next weapon is not equal to current weapon dot weapon underscore name. We want to make sure that we're not changing into the same weapon. If animation player dot get current animation is not equal to current weapon dot deactivate. You can run any other checks here. This is what the exit function is for. Any kind of check that you want to make sure that you can actually change weapons. So I'm going to check that the animation player isn't already playing the current weapon dot deactivate, and I'll play, if that's all true, I'll play the deactivate animation and I'll set the next weapon equal to the underscore next weapon, which is what we passed into the function. Okay, so how do we actually change weapons? Well, we're going to use a signal from our animation player. I find this is a good way to just control the rhythm of things and make sure that we're not spamming animations. So animation finished is the name of the signal that we want to connect. It's the second one down here. So just double click that and then click on Weapons Manager. And it's going to have a variable, a nim name. So we want to take that variable and we want to check if it is equal to current weapon dot deactivate a nim. So I'm just going to type this out now. If a nim name is equal to current weapon dot deactivate underscore a nim, then, oh, got an L. Okay, so semicolon or colon, change weapon, and we're going to pass in a string. I'm just going to type this in here, weapon name, capital letter string, and in change weapon, we'll pass in next weapon. Of course, you could easily access that from change weapon, but I just feel like this is a little bit safer. Now, in theory, we've done all our verification already, so we know we can change into this weapon. So change weapon can just be nice and simple. I'm going to remove the pass here, and current weapon is equal to weapon list, square bracket, weapon underscore name. And that'll be it. And obviously we'll clear out next weapon so that it's blank so we don't have any problems there. And we'll call the enter function and we'll go around to the next one. Now that we've got that all set up, we can run and do a test. And as you can see, when I press the 1 or 2 button, I swap weapons. Now, I shouldn't be able to swap weapons when I spam the 2 button. If I'm trying to continuously go up, it should just call up the same exact variable for weapon indicator, and then obviously we're the same, so it wouldn't work. So, okay, so the first thing that we want to do is we're going to add some functions. We're going to add function shoot, and I'll just put a pass here, and we're going to add function reload, and I will put a pass there as well. If you remember from our last tutorial, we set up the inputs for these. So we want if event is action pressed shoot, we're going to shoot, and if event.isActionPressed reload, we're going to reload. So if you haven't got those inputs, you just go project settings, and under the input map, just type shoot in there and hit add, and I'm going to put that under the left mouse button. Then I'll add the reload. So just press add and hit that little plus button, and I'm going to put mine to R. Okay, so I'm just going to put in these animations. So I'm going to call the animation player.play, and I'm going to pass in the current weapon.shoot_anim. If you guys remember, we've got these resources with the animation stored there as variables. So my variable is shoot anim. If you don't have that, just pass in whatever animation you want to play. Same exact function below there, animation.play, current weapon.reload, and we'll hit play there. And you can see immediately that the gun is playing that shoot animation. And when you press R, it is reloading, which is exactly what we want. So everything's working. If it's not working, check your animation variables. I am going to set up a HUD so that we can, keep track of what we're doing. So I'm going to create a bunch of signals here. Signal 1 is weapon changed. Signal 2 is update the ammo. And signal 3 is update the weapon stack. I'm going to need to create a canvas layer here. I'm going to drop that up below the parent node. We'll add a couple of V boxes, and right below that we'll add H boxes. And then we'll need 2 labels. Now that first label is just going to be the name of the particular field we're keeping track of. So I'm not going to worry about renaming it, but the second one here, I am going to rename to current weapon. And in that top label there, I'll just type the text current weapon. I'll duplicate that. Yeah, let's rename this field to be ammo with a colon and then a space, and then rename this actual label here below it with nothing in it to current ammo. Same thing again here. Let's retype the text in to be weapon stack and rename that label below it to be weapon stack. And we'll create a new script on the canvas layer in the tutorial folder. That's fine. We're going to call mine HUD, and we're going to add all 3 of these nodes. So at onReadyVar, we've got current weapon label equals, and I'm just going to drag that in. You'll see the new show up on this. I didn't notice this when I was doing it, so I'm going to have to fix that later. We've got onReadyVar current weapon current ammo label, and drag that across again. I have the same problem with the new, just ignore that. Delete it if it happens to you too. And at onReadyVar current weapon stack, and drag that node in as well. Okay, so now let's connect up those 3 signals that we created. We'll double click those and click the canvas layer. Okay, so now we have all 3 signals here. We are going to type some variables here. We want the weapon name on weapons manager weapon changed. And the function we're going to call is current weapon label dot set underscore text, and we'll just pass in the weapon name. Okay, so for the update weapon stack, we're going to do something a little bit different. We will pass in the weapon stack, and we will type current weapon stack dot set text, and we'll actually pass in nothing so that it gets cleared out. And for I in weapon stack, because it's going to be an array, will be current weapon stack dot text plus equals, and then we'll put in a new line and we'll add in I, which will just be the name of the weapon. And for the update ammo, I'm going to do current ammo label dot set text, and I've got some brackets here. str is the function to change an integer to a string. I'm going to pass in ammo, almost forgot that, and that's going to be an array as well. So I'll type ammo square brackets 0. I'll add a slash, and then I'll do plus str ammo square brackets 1. So that will be our current ammo and our reserve ammo. And make sure you get your brackets right here. It can be a bit confusing when you're adding all these functions. Okay, so we'll come back over to the weapon stack, and we need to actually emit these signals. So on initialize, we want to update the weapon stack, and we need to pass the weapon stack to the HUD. And when we enter, we are going to emit the signal weapon changed with the current weapon dot weapon underscore name. And we'll also need to update the ammo because we've changed weapons. And that will need to be an array, current weapon dot current ammo, comma, current weapon dot reserve ammo. Okay, so here they are, these two variables in my resource. If you're not using these resources, then you'll just need to pass in whatever variable you're using. Obviously, this is going to crash because of those new functions that appeared when I started dragging these in. I'm just going to remove them, delete them out, and rerun the game. And there we go. We can see it says Blaster D, ammo 30 of 60, and the weapon stack, which is the two weapons we have in our possession, Blaster D and Blaster N. And when I change, the ammo is updated and the weapon name is updated. Okay, so now we can start setting up the math for the shoot and reload. We're going to come to the shoot function and we'll just add our first condition. We're going to type if current weapon dot current ammo is not equal to 0, colon, and then we'll drop down. And we're actually going to add a second condition after this. We could, of course, do this in one, but I prefer, or I feel like it's more readable to have it as 2 in this instance. You guys can do whatever you like. I'm going to type if not animation player is playing. So we don't want to shoot when the animation player is already playing. In other words, we can't interrupt an animation to shoot. So this will also enforce the fire rate set by the animation. And then I'll have my animation player dot play. And we'll also need to reduce our ammo. So we'll have current weapon dot current ammo minus equals 1, and we'll emit this signal update ammo. And I'm just going to come back up to the enter function and just copy that in because it is quite long. Alrighty, so let's hit that play, and you can see that now our ammo is reducing and our animation player is playing. When we reach 0, nothing happens. The other thing we might want to set up is auto fire. Come to the signal for the animation player, animation finished, and I'm going to type if anim name is equal to current weapon dot shoot anim and current weapon dot autofire. So you'll remember in our resources we have an autofire variable. Make sure that's equal to true, and then we're going to check if input dot is action pressed and that shoot. And then if that's true, we're going to play the shoot animation. As the animation finishes, if the autofire is set to true, we'll run the function again. So as you can see, that's working. As I hold down the fire button, that animation for the Blaster D is playing on repeat. Okay, so now what do we do if we run out of ammo? We need to reload. So I'm going to type else reload, and I'll come down to reload. Okay, right now we're just playing the animation. So we need to do a few more things. Let's have a look. We've got reserve ammo, we've got magazine, and those are the two variables that I'm going to be playing with in my resource. So I'm going to check if current weapon dot current ammo is equal to current weapon dot magazine. That is to say that we don't need any ammo. I'm just going to return out of this. Nothing's going to happen if you have full ammo. And then I'm going to check that if the animation player is not playing. I don't want to do this if we're in the middle of something. I can't interrupt to reload. And that's mostly a design choice. It doesn't have to be that way. And then I'm also going to have another condition after this. And it's going to be if current weapon dot reserve ammo is not equal to 0. We can't reload if we don't have any ammo. And then I will reload. Okay, so that's all the conditions that we need. Okay, so this is how we're going to do it. We're going to type var reload amount is equal to, and we'll use the min again. I'm going to make this a little wider because it's going to be pretty long. I type min, and this can take any number of variables. So we're going to type all of them here. So it's going to be current weapon dot magazine minus current weapon dot current ammo. So think of that as if we have a magazine of 10 and we currently have 3 in our current ammo, the number there would be 7, which is the amount of ammo we need to fill up our current ammo to our magazine level. Okay, the next one is going to be the current weapon dot magazine, which would be, in my example before, 10, And the third one will be current weapon dot reserve ammo. So it's going to be the smaller of these three numbers. In most circumstances, it's either going to be the lesser of those three. So if you don't have enough ammo to top your current ammo up to full, then you're going to just take the reserve ammo amount. If you are at 0, then current weapon.magazine minus current weapon.current ammo might be the same as current weapon.magazine, now that I think about it. So you could probably just do the two. Either way, it's always going to take the lesser of those three situations. Anyway, okay, so what we want to do with this is we're going to type current weapon.current ammo, and I'm going to go equals current weapon.current ammo. I like this to be written out here, just so it's clear what I'm doing. Current weapon.current ammo plus reload amount, and current weapon.reserve ammo equals current weapon.reserve ammo minus reload amount. Okay, and lastly, we want to emit that signal for update ammo. And the else condition will be else we will want to play the current weapon.out of ammo animation. So that's the animation I have stored in my out of animation variable in my resource. Okay, so let's test this out. I'm just going to empty the clip on this one, and it should reload 30, and my reserve ammo is 30. And I'm just going to do a couple of different tests to make sure we're happy with the number that's always coming out. So 25, I need 5, yep. Okay, I need 10, yep, okay, that makes sense. And I'll reduce it all the way down to 10. I should go up to 20, and I do, and now I don't have any ammo. What happens? Then the out of animation plays. And same when I get to the end. I'll test this one out too, just to make sure. And it looks like it's reloading normally. Okay, so that is how you set up the reload, the shoot and reload animations and all the math that goes along with tracking the ammo. The next one, we're going to be looking at the Hitscan. So we're going to actually start to be able to shoot our gun, I guess you would say, going to be able to deal damage. One last thing that I wanted to do before I left this one was just add a sight, because we don't have one, so you don't really know where you're shooting. So I'm going to hit that plus. I'm going to add a texture rect to the canvas layer, and I'm just going to call that main sight. And I've got something in the models under HUD assets called Crosshair 1. I am going to click the little anchor up the top when I have the main sight selected and select a full rect and drag that texture over to the texture slot on this texture rect. You'll notice that it's very stretched. What we want to do is change the stretch mode to keep centered and just make sure that anchor is selected. And now you'll see when I run, it is in the center. Okay, so that is how you set up the shoot and reload in Godot. That's just the animation and a quick and dirty little HUD to keep track of it all. In Godot 4, there's something called a physics ray query parameter 3D. I think that's the right term. And you can use that to create a raycast from wherever you want to wherever you want. And what we're going to do is we're going to raycast from the center of the camera out to a determined range. And if that ray intersects with something, we are going to do another raycast from the barrel of our weapon to that object. This is an extra step just to give us a little bit more accuracy, so that if there's something in between the barrel, like a box you're hiding behind some kind of object, you can't just, peek out of it and shoot. You could, of course, just raycast directly from the center of the camera and get pretty similar effects, of course. And that is not what we want to achieve here. So we're going to do 2 raycasts, and let's get into it. So the very first thing that we need to add is a marker 3D. It could be also a node 3D. That's fine too. I'm going to call this a bullet underscore point. And the trick here is with the animations, we're going to move that bullet point to be right at the barrel end of the gun. So I'm just going to manipulate that into the right position for all my weapons and just key that frame in on my animation player. So you'll see I've put that there, and I hit the key button on my blaster to deactivate. So when the gun's activated, that marker moved into position. And for the deactivate, I'll hit the reset and key it in. This is not super necessary, but I think it's just a little bit better that way, just in case there's any issues. I'll come down to Blaster Eye and I'll do the exact same thing. I'm going to speed through this. But yeah, for every single one of your weapons, you want to move this bullet point in front of the barrel where the bullet would come out of, essentially. And we're going to use this for both our hit scans and projectiles. Okay, so after you've set up your animations, right-click the bullet point and select access as your unique name. We'll come into our weapons manager script and we'll type onReadyVar bullet underscore point equals get node, brackets, quotation marks, and then the percentage sign, and then bullet point. The reason I do it this way is just in case you want to move things around after you're done. Makes it really easy. Okay, so we'll come into our weapons resources script and we're going to add a couple of variables. First thing we want is an export flag. So that's export underscore flags, and we'll do one as Hitscan and the other as Projectile, and we'll call it type. So this is a really cool thing. It'll give us an enumerator that we can use to decide what kind of gun we're shooting. The next export variable is weapon range, and that'll just be an integer. It's pretty straightforward what that'll do. And then we'll have export var damage as an integer as well. And so we'll come and set these up. I'll make this one here, Blaster D, a hit scan weapon, and the same with Blaster I, and I'll give them all 2000 range for now. We'll come back to our weapons script and we'll create an enumerator. It'll be between 3. We'll do null, hit scan, and projectile. And I think you can probably see where I'm going with this. Okay, so in our shoot function, we're going to type match current weapon dot type, and we'll have null just in case it's not been selected. I'm just going to put a print here and say something like weapon type not chosen, and then hit scan, and we'll put pass for now, and then we'll also put projectile, and we'll do the exact same thing. We'll just pass there. The first thing we need to do before we actually start doing our hit scan is we're going to need to get a raycast from our camera. So I'm going to create a function called get camera collision, and we'll start working on this. We're going to just type pass so that I can set up the rest of the function in shoot. So I'll type var camera collision equals get camera collision, and so for the camera collision, we need to get access to our camera. So we can just go var camera equals get viewport, get camera 3D. And it's going to return the active 3D camera, which is going to be the one that we're using in most cases. And then we also need to know the size of the viewport so we can project the raycast from the center. So we'll get viewport dot get size is the function we're going to use. And we're going to have ray origin equals camera dot project ray origin, and it's going to be a screen point, which will be our viewport divided by 2, so that'll be the center. Okay, and the other one will need to be ray end, and this will be ray origin plus camera project ray normal, and it'll be the viewport divided by 2, which will be the center again, multiplied by the current weapon dot weapon underscore range. So that's how far we're going to project our raycast. So we'll have the next variable, which will be a new intersection, and that'll be equal to physics ray query parameter 3D dot create, and we'll take a from vector, which will be our ray origin, a to vector, which will be our ray end. This is new in Godot 4. I'll just make some space down below and make this a bit wider. So that's a new function we need to call when we're raycasting. And the next thing we need to do is just get a variable for the intersection, and that will be equal to get world 3D dot direct space state dot intersect ray, and this now takes a physics ray query parameter 3D. So we'll pass in our new intersection. And then what we'll do after that is if not intersection dot is empty, and we'll get the collision point, and it'll be equal to intersection dot position. So that'll be the world point of the actual collision. And we'll return that, else we'll just return the ray end. This is not important for the hit scan, but it will be important for the projectile. So keep that in mind. So no matter what, we're returning a vector 3, and it's either going to be the point that we hit with our camera or just the end point. Okay, so we can come back up to our shoot. And now that we've got that point, we can start working on our hit scan. So we've got the function hit scan collision. And I'll just type pass in there. It's actually going to take a variable, which will be the collision point from the camera collision function. Var bullet underscore direction is equal to collision point minus bullet point dot get global transform dot origin and dot normalized. And so that'll give us the direction that this new vector should be traveling. And we'll type var new intersection. This will be pretty similar to the one above, and that'll be equal to the same as before, physics ray query parameter 3D dot create, and the from point will be the bullet point dot get global transform dot origin, and the 2 point will be the collision point plus the bullet direction times 2. Now you give it a little bit of extra. The multiplication of 2 is pretty much to just push it a little bit further than what you would need, because what I found is if you don't do that, this hit scan collision doesn't always register a hit. Okay, so we'll come down with var bullet underscore collision, and we'll get world 3D dot direct space state dot intersect ray, which takes a physics ray query parameter 3D, and we'll pass in that new intersection. And now we'll know if we've actually hit something. So we'll go if bullet collision, print hit scan damage. And so we'll just print that out. We know we can deal damage at that point. So I'll create a function called hit scan damage, and we'll just set it to pass at the moment. And we'll set this function up, call that function under if bullet collision, just so that it's more complete. This is the exact structure we want. Okay, I'm going to toggle out of this, and we'll come back to the world, go back to 3D, and we'll bring the editor back. And I figure the box will be the best thing to work on. So let's interact with that. So I'm going to add a group. So if you come over to Node, where signals are, and just click the little icon that says groups, click manage groups, and type target in this box here, and add. Select the physics object and add, and then press OK. Let's add a script. Under tutorial, I'll create a new folder called world underscore objects. And I'll call the script physics target. And under here, I'm just going to say var health. We'll just give it like 5. And then we'll create a function called hit underscore successful. Try to spell that right, hit successful. And we'll pass in the damage. And then we'll just go health minus equals damage. This is just a simple one. And then we'll check the health. If it's less than or equal to 0, then we'll keyfree. Nice and simple. We'll also print the health as we go, just so that we can keep track of, make sure that it's working. Okay, we'll come back over to the FPS character. And under here, where we've got our hit scan, we'll pass in the collider, which is one of the objects returned from intersect ray. So bullet collision dot collider. So we'll type if collider is in group, and we'll just type target and the collider dot has method, and we'll type that method out before it was hit underscore successful. It's important to make sure that's correct, otherwise this won't work. It's also important to make sure that you do this just in case you don't have that function on the object you're hitting, otherwise your game will crash. And we'll just type collider dot hit successful, and we'll pass in the current weapon dot damage. Cool. Okay, so everything should go to plan. We just need to make sure that we come up to this match in the shoot and actually call that hit scan collision function and pass in the camera collision. After that, we should be good to go. I just once check over this. Yep, I think we're ready. Let's run the game. Okay. Oh, we got a crash. Oh, yeah, okay, so health is int, and I've been writing too much JavaScript, so I just need to type str health. Okay, and then you can see it's gone. And that's working. So that's how you set up a Hitscan weapon. Awesome. And it's not interacting with anything else. Okay, so that's pretty cool, but we can't always see where we're shooting. So it'd be nice to do that. So let's come back over to our project and we'll just create a new scene and we'll make it a sprite 3D. This is just going to be a simple we'll call it a bullet underscore debug. And under hard assets, I've got a crosshair. That'll do just fine. X marks the spot, if you know what I mean. And I'll just make it red. I'm also going to come over to the flags, and for billboard, I'm just going to put Y billboard so that's always facing the camera. And I'll save that under weapon resources. Not really much to it. I will create a script, and also I'll add a timer, and I'll put the timer just 1 second's fine. Connect signal timeout to the script, and once that timer times out, I'll queue free. All right, cool. And I will add that scene as a variable here. I'll type var debug underscore bullet, and I'll preload, and I'll drag that scene over. Debug bullet, just drop that in there like so. And I'm actually going to take those out of the weapon resource folder because that's where we keep all the, okay, cool. I've moved those just to make it a little bit neater in my project. So I'll just have to reset that preload. So every time you move this file, you're going to have to relink that up and drag that back over. So it says tutorial bullet debug. Okay, so now we need to instantiate that. Probably if there's a collision, I'll type var hit underscore indicator equals debug bullet dot instantiate. I'll type var world equals get tree dot get root, and I'll just add the child hit indicator, and I'll set the transform. So hit indicator dot global translate, and it'll just go bullet collision dot position. So that'll show up at the position of the collision. And there you can see it. And they're not disappearing. I suspect that's because I forgot to set that to auto start, and they'll start disappearing. So now you'll always be able to see where that hit scan is going. So that'll just help as you're building your game out. You just replace that with a decal when you're ready. And you'll notice where it's showing up in the tree. I don't know if I'm a huge fan of dropping it in the root. Maybe we could move it to the world. It probably doesn't matter that much, but I'll come back over to the FPS character, and where we're instantiating that, where it says get tree dot get root, I'll just get child, and I'll just type 0 there, which will be the first node, which is going to be the scene that you're in, you know, the level. In most cases, depends if your game's more complex, but if your game's more complex, I suspect you don't need this tutorial. So, and now you'll see it just shows up in the world. Probably not that important, but I just thought it might be important to point out that, you know, to think about these things when you're just instantiating stuff. Okay, that's it. We've done it. Hit scan weapons. We'll do projectiles next. Now we've set up our camera collision. We've got our hit scan done. Let's come in and set up the projectile. We just need to create a function. But first, let's jump into the weapon resource and create some variables, because if we're doing a projectile, we need to spawn something. So I'm just going to move this export flag down, and below this, we're going to create a new variable at export var and we're just going to call it projectile to load. And that's going to be a packed scene. So this will be the scene that we instantiate when we create a projectile weapon. Next, we're going to create the projectile velocity. This will be how fast the projectile goes. If you're creating perhaps a rocket launcher, you want it to go a little slower, but if it's a bullet, maybe it needs to go a little quicker. Okay, now I'm going to choose one of my weapons. I'm feeling Blaster N. I'll come in with Blaster N and I'll change it to a projectile. So make sure at least one of your weapons is marked as projectile. So now we've got Hitscan on our assault rifle, but on our other weapon, there's nothing happening. So let's come in and set that up. Let's create first a projectile velocity. I'll just choose 100 to begin with. And we need to create a projectile. So I'm going to use one of Kenny's foam bullets, probably this one here, foam bullet A. So I'm going to create a new scene and I'm going to click other node and I'm going to grab a rigid body 3D and I'm going to rename it to bullet. And I'm going to drag that model in and make local and then just get rid of all the other nodes and keep the mesh. I'll need to reset the transform on that. So I'll just do that quickly. And I'll just rotate it so that it's horizontal on the Z axis. That's pretty important for a bullet. We'll save that scene under our tutorial folder. Now I'm just going to bring in the gun model just so I can see, how this is going to look in comparison, if I need to make any changes to it. And I think I am going to make it a little bit bigger so we can look, it is the right size, but I think it could be bigger. So I'm going to make it a little bit bigger. I'm going to delete that gun and reset the transforms. Now I'm going to play around with the material. You guys don't need to do this, but I think because it's a laser, it's going to be emissive. And so I'm just going to set up an emission, make it super bright, just because it looks cool. Nothing really, no other reason. Okay, you can choose multiply, but it doesn't really look that good. So add is what you want to keep for the operator. And we need to create a rigid body. Now I'm going to create a capsule shape and I'm just going to obviously rotate it and we're going to need to make it substantially smaller. The trick with rigid bodies, turn off snapping here, is that you want them to be a little bit bigger than the projectile that you're actually shooting, because I don't really know with Godot 4 if the physics is worse. In Godot 3.5, you couldn't really use projectile weapons for like fast shooting weapons. You could really only use them for like rocket launchers and things like that, because the physics engine could not detect the collisions 100% of the time, and you had to do a lot of like trickery to get it to work. But at least in my testing with Godot 4, it seems to be significantly more reliable with the new physics engine. So I'm going to go ahead and set this up, and you shouldn't really have any issues, but if you are having problems, it could just be engine related. Just keep that in mind, I guess. I'm going to select continuous CD on the rigid body, and I'm going to set the number of contacts to 10 and select contact monitor. This will allow it to detect collisions. I'm going to reduce the mass to 0.1 and I'm going to create a script. Okay, so the first variable is obviously the damage. We're just going to set that up as an integer and it's going to be 0, but we'll work on that. I'll explain that in a second. And we'll connect the signal up, body entered, to this script. And we'll go if body.isInGroup, brackets target. This is a group we set up in our previous tutorial on Hitscans. And the body has method brackets hit successful. So those two things are required here. So if you don't have a group, set it up now. And you'll need a method on the thing you're trying to shoot called hit successful. And we'll call that function if both of those are true. And we'll pass in the damage. and we'll queue free, and then we're gonna queue free regardless. You could just put that on the outside of the if statement as well. I'll also create a timer just in case we don't hit anything and this goes flying off into nowhere. We'll just delete it after a certain amount of time. Okay, that should be all we need. We can close up these folders, make things a bit neater. We can jump back over into our blaster resource, and we're going to drag that projectile to load into that resource there so that we have that on file. We can come back over to the weapons manager now and we can start setting up our projectile method. So we've got our camera collision. This is an important function. If you don't have this, you definitely need it. We are going to be returning the collision point or the end of the ray. So we're going to always have a place to send our projectile. So that's why we need to return the ray end, just in case you shoot into nowhere. So under projectile, I'm going to create a function called launch projectile, and I'll pass in the camera collision. I'll create this function down here, function launch projectile, and it will take a variable called point. The first variable that we need is the direction, and that is going to be the point minus the bullet point and get global transform dot origin. And we're going to normalize it. This will be pretty familiar if you've done the Hitscan. Next, we're going to need to instantiate the projectile. So I'll create a variable called projectile, and I'll say current weapon dot projectile to load dot instantiate. And I've just realized that I've made a spelling error, so I'll come up and fix that. Next, we are going to need to instantiate this bullet. So just make sure that the bullet is set as top level for this, because we're going to instantiate it under the bullet point, which is a part of the kinematic body. So under bullet point dot add child, we're going to add the projectile, and the projectile dot damage we will set to current weapon dot damage, and then projectile set linear velocity, and that'll be the direction multiplied by the current weapon dot projectile velocity. So just make sure that the bullet is set as top level for this. So that's super important. We also need to set up the collisions, layers. I haven't explained these yet, but one thing I've noticed is that with Godot 4, the physics bodies do need to be on a separate layer. So they weren't working for me when I originally set this scene up. And so now I've created a physics layer called objects on layer 3. And layer 4 is the weapons. So make sure you set your projectile to have the same collision layers as well. We're going to put it on the third layer, and we're going to have it mask layer 3 and layer 1. So it's going to interact with anything on the world layer. And keep in mind with your enemies, if they are on a separate physics layer, to make sure to select that mask here for your projectile. So here's the box. It is on layer 3 and it's masking 1, 2, and 3. So it can interact with anything on those 3 layers. Let's run the game here. We'll swap over to the weapon that is a projectile, and you can see it is spawning those projectiles and shooting them. And then we'll shoot the box, and you can see it rolled. It's definitely hitting it, and you can see below in the console that the target health is being reduced. So that is working how we've expected it to, which is really amazing. It is just that easy. Okay guys, it's Isaac from the future here to interrupt this projectile tutorial. I found a slight bug in the code. I don't know if anyone would have picked up on it or even noticed, to be honest, because it's just something that can happen
but it might not depending on how you've set things up. So you won't see it actually in the video, but I did notice it when I was playing around with like a big projectile that you're shooting and you're shooting it rapidly. Something that happens, I'll play this here. I've made a couple of changes to this project. It's been a long time since I recorded that original, but here's the gun and this is a projectile. So it's quite a bit bigger and this has been changed to automatic. So if I hold this down, watch what happens. Look at these last two. They start going off in a completely different direction. Now you might wonder why, maybe you've already worked it out, but it is basically the raycast from the center of the camera interacting with the actual projectile rather than going through that and hitting the thing behind it. So that will change the trajectory of the projectile because the direction that we send it will be just based on that reduced distance, right? So the bullet is much closer to the player than the wall is over there. And so it's just going to go in a completely different direction and it won't line up with the reticule in the center of the screen. So it's going to be pretty noticeable. You can tell it veers off like that, which is pretty weird. So I'm going to quickly show you guys how to fix that. I'll jump back over into the project. Things are going to look a little bit different, but you'll just have to bear with me. We have got our camera collision, and then we've also got our launch projectile. So the flow of the code is essentially, if I come back up to shoot, you can see that I'm getting the camera collision, which is we're shooting a raycast from the camera to wherever. If it's hitting a wall, it's coming back. If it's not hitting anything, it's just coming back with the farthest point away. And then we're passing that to the launch projectile and we're throwing that from the bullet points. That's the muzzle of the gun is where that projectile comes out and it goes towards that end point wherever it's collided with. And generally that's meant to be at where the center of the camera is. So that's why it hits that reticule. But obviously if it's hitting the bullet, that's like not where we want it to go. And so it's not going to line up and it's going to look weird. So what we need to do is we need to add an exclusion to this physics ray query parameter 3D. And it's got a exclude. And we can set exclude and we can pass a value. It takes an RID. So we need two things, right? We need to get the RID from the bullet, which is not that complicated. What we can do is we can set up an array. I'll do it underneath this enumerator here. So I'll go var collision underscore exclusion. And I'll set this equal to just like a blank array. No, that's not the one I want. There we go. And I'll come back down to the launch projectile. And what I will do is after we've added the child, actually after we've instantiated really, we can do it. We can get the projectile, we'll create a variable called var projectile underscore RID, which will be equal to projectile dot get RID. This is just a built-in function for any collision object. And then we will just go collision exclusion dot push front, doesn't really matter. Projectile RID. I actually think pushback is faster, but we're not going to store that many. So now that we've got that being added to an array, what we can do is we can come back up to the physics ray query parameter 3D, and right after we create it, we can just write new intersection dot set exclude. I think that was set exclude, and it takes an array, and we'll pass in that collision exclusion. And now that won't happen anymore. So let's run the game. Switch to our gun, and you can see that it's going straight ahead perfectly anytime. But now we've got a new problem. The new problem is we're creating an array of RIDs and it's ever growing. And I've stress tested this and you can get to about 5,000 before the game will crash. So we need to remove these as they are removed from the scene. So we need to, right after we have created the projectile and we've added it to this exclusion array, we need to also hook up the tree exited signal of the bullet
to the weapon manager. This is the bullet node, and under signals, we've got tree exited. So this is emitted after the node exits the tree and is no longer active. Okay, so like I said, we need to hook up that tree exited signal. So we'll also need to set a func, and we'll go remove underscore exclusion. And this will take a projectile underscore RID. And then all we'll do for this, I'll write this code now. We'll go collision exclusion dot erase, and then we'll pass in that projectile RID. And I'll also spell that right. Put an E on the end. Oh, 3 like a badass. Okay. And just set that up like that. So that's all we need for the exclusion. Now we just need to link that up with a signal. Now, signals have changed a lot in Godot 4. And one thing I was learning as I was doing this is that you can just call directly a signal. So it needs to look like this. So we can go projectile dot tree underscore exited dot connect, and then brackets, and then it just needs to be remove exclusion dot bind. And then in this, I can pass the projectile RID, but I think it should be projectile dot get RID. So you can see off to the right here, I'm creating that, and you can see it grows as I move further back. It's kind of hard. I wonder if I just like send these out. This is probably the best way to do it because they expire after 10 seconds and they'll just delete themselves. So you can see it grow up to 21, and as they delete themselves, they should get reduced, and you can see them going down like so. And so that, in my opinion, is the best way to solve this issue that I showed you before, where it's not going directly to the center. What we need to do, just to recap, is to get the projectile's RID and add that to an exclusion list for our physics ray query parameter up here in the camera collision. You add that to the exclusion of that, and it won't actually, the raycast from that won't detect the bullets, which is exactly what we want, but also we need to remove those from that array as time goes on, because an array can only get so big before the game crashes, as I've discovered. Might be obvious to some people, I don't know, it surprised me. And yeah, so you hook up the signal like this, projectile.treeExited.connect, remove exclusion.bind, projectile.get RID. It messes with the head a bit, this new signal thing, but anyway, that's how you do it. If we run the game as it is, you can see our Hitscan weapons don't do anything, but our projectiles certainly do. Okay, so how do we go about fixing this? Well, if we jump into our box, we can see that we've got a simple hit successful function that takes the damage and applies it to the box. If it reaches 0, then we call queue_free and it disappears from the scene. The function that is controlling that at the moment in the Hitscan branch of our weapon system is a function called Hitscan damage that gets called after a collision is detected via our Hitscan collision function. And right now, we're just passing in the collider, and we're checking that if it's in a group called target, and if it's got the function called hit successful, we're going to call that function and pass in the damage. So not a lot to go off, but we can use some of the information from our collision to work out the direction it should be moving. So we need to pass in a couple of extra parameters, and we'll name them here. We'll call one direction, and the other we'll call position. Okay, and I'll just come back up to where we're calling that function, and I'll write bullet direction. We've already got that at the very start of this function. We've got bullet direction equals the collision point minus the bullet point dot global transform dot origin normalized. So that is the direction of our Hitscan. So that's essentially where the bullet is coming from, if there was a bullet. And the next thing we need is position. Now we can get this from the bullet collision dot position. This is a field that's returned from the getWorld3D.directSpaceState.intersectRay function. It's something that is returned when that collides with something, and it's the world position. We'll jump into that function here, and you can see that is the intersection point. So that is where that position is in the world space. And we can use that to determine the position of our target. Now if we come back into here, passing in both of those, and what we need to do as well is where we're passing in collider.hitSuccessful, we also want to pass in the direction and the position. All right, now we just need to jump back over into the box and update the hitSuccessful function here. Here's a little trick for you. I'm going to write underscore direction colon equals vector3.0. And what that will do is actually make these parameters optional so that we can still use it with our rigid body projectiles that we're firing, and we can reuse this function on other targets that might not need this information. And the next one that we need to call is obviously position. And we'll do the exact same thing, underscore position colon equals vector3.0. Okay, so we'll do a quick run of the game here, and just to show you that we haven't changed anything, we're passing in those functions, and our shooting in this game hasn't changed at all, so everything is still working. Those are all optional parameters. Our projectile is just passing in the damage, and the rest is all just going to be 0. So we can come down here, and we'll need to create a new variable called hit underscore position. And this will be a little bit of math here to work out the position of the actual hit. And it'll be equal to underscore position minus get global transform dot origin. And we'll come down at the bottom of this function and we'll say if underscore direction is not equal to vector3.0. So we're just going to only run this if there is information being passed in. Otherwise, we're not going to do this. And we'll call the function apply impulse. And this will do exactly what it says on the tin, really. It's going to apply an impulse, which is a force at the position. And so our impulse is going to be, or at least the way I like to do it, so that it sort of scales with the power of the weapon, we're going to call direction, and we're going to multiply that by damage. Now, the reason that the impulse is going to be in the direction is because we want that impulse to be in the direction of the bullet. So essentially, that's why it is direction for the impulse, and we're multiplying that by damage to sort of give it a little bit more oomph depending on the weapon or whatever it is. And then the next is going to be the position, which we calculated at hit position, so I'll pass that in. And that's all we need to do. We can run the game, okay? So you can see now that the box is reacting to the hit scanned weapon and it's disappeared. Might add some health while we play around with this, just so it's a little bit easier. Okay, you can see me lay into this. It doesn't matter where I shoot it, it seems to react in a sensible way, which is exactly what we want. And you can see if I shoot it with the projectile weapon, obviously there's a lot more force behind that, but this is something you can tweak. You can change the mass of the bullet to sort of give it less force. And so we can jump back into our project and do that so that it feels similar depending on the gun. It's just going to depend on what you're trying to do and how you want things to react. But you know, that's the function you need to do. I'm not sure if it's 100% physically accurate, but it's good enough and it's easy enough to implement, right? And since we're shooting this rigid body, I thought it was a good time to show you. So we can come back to the bullet and we can reduce that mass from 0.1 kg to 0.01, so it's a very light bullet. And we can rerun that, and then, okay, that feels pretty comparable, I would say, to what the Hitscan done. It's a little bit more, but I don't think people would really notice that much. So now you can shoot rigid bodies with both weapons and they react the same, which is pretty cool. Now, while we're here, I think we should just add in a static body. So I like this particular mesh called target B. And I'll come back into the project and I'll create a new scene by clicking on this plus. I'll press other node and I'll search for static body 3D and I'll drag that model into the scene. I'm going to right click and make local, get rid of all these extra nodes and delete them. And then I'll click on the target. I'm going to be a little bit lazy here and just go mesh single convex collision symboling. This isn't the most efficient way to create a collision shape, but it certainly is easy. Now I'll save this here in the tutorial folder and I'll just call it something like target. I'll reset the position because everything is a little bit off, so I'll just change that, make sure it's on 0. And I'll rename this static body to be something like target. Okay, so we'll create a script next and we'll save it in the tutorial folder and we'll call it something like static underscore target and we'll create that. And we can pretty much just copy the code from our rigid body. I'll just copy this first bit. We don't need as much because obviously it's not going to react to the direction and position, but we do need it because it's getting passed in from the player. So we'll bring that over, copy it, and I'll just enter down here and I'll paste this in. And right below this, I'm just going to write pass for a second and I'll create a variable called health like before, except this time it's just going to have 1. And under hit successful, it'll pretty much be what we started with the box. We are going to subtract the health. So health minus equals damage. And if health is less than or equal to 0, then we will queue free. Nice and simple. That's all we need, but we do need to pass in those 2 optional variables just to keep our player character happy. If we don't do that, this will crash. So I'll add a node to the scene and I'll just call it static targets. And I'll navigate to that folder and I'll just add that to the scene. Okay, I'm gonna drag it over to this wall over here just so that we have something to shoot at. Okay, it's nice and positioned on the wall. I'll raise it up a little bit and I'll just duplicate that a few times so that we've got something to shoot at. I might skip this section because it's kind of boring. Okay, and before I forget, we do need to add this static body to our group called target. So I'll open that scene again and I'll come over to the node tab on the right hand side where it says inspector node history. I'll click node and I'll click groups here and I'll click manage groups. I'll type target, add, click the static body, click add, click OK. And that's all we need to do. Just save that scene. Make sure it's the same as the one for the box. You can have multiple groups if you want, and you could be calling different functions on those as well. That's totally fine if you want to do it this way. I'm just running them both in the same group and having the exact same function be called. All right, so we have a look at these and you can see that they're getting deleted successfully. All right, so that's how you add in physics reactions. It's how I like to do my static bodies as well. Just a nice, simple way of dealing with targets, having a single function that's being called and the 2 variables that aren't required all the time be optional. Okay, so if we want to be able to pick up our 3 weapons, then we need to create rigid bodies for all 3 of them. So I'll create a new scene here and I'm just going to navigate to where the models are and I'll click other node. And it's going to be a rigid body, so I'll search for that and select it. I'll rename this to the name of the weapon that I'm creating. So for this one, it's going to be Blaster M. I'll drag that model in. I'll make it local and I'll just delete these empties like you've seen me do a bunch of times before. I'll also reset the transform on this. So come down to transform, just reset that so it's in the center. And the easiest thing to do to create a collision shape is just click this button here where it says mesh. I'm going to go with single convex collision. It's a pretty good in-between shape. And as you can see, I've got a collision shape that pretty closely conforms to the shape of the weapon. And I'll save this. I'll create a new folder and I'll call it spawnable weapons. And I'll hit save on that scene there. Okay, so I'm going to do the same thing for the other 2 weapons. I'll speed through this. Okay, so I've got my 3 rigid bodies all set up and now we can add a script to this. So I'll hit this little script button and I'll actually call the script something like weapon pickup because we're going to use this in all 3. And I'll type export var weapon name. And that is going to mirror exactly the name of the weapon on the resource. So we'll just make that an export variable, so we don't need to name it here. And the next one will be the current ammo. So this will be the ammo that sits on the weapon when you pick it up or drop it. And the third variable will be reserve ammo as well. You could have one variable for ammo, but I think it's just a little bit easier to have two, to be honest. But it's really just a design option at this point. So we'll drag that script onto all three of these, and we'll also name these weapons. So just make sure that they're the same as your resource. You come back over to this. If I click on the weapon manager and I've got all three of these, weapon name, blaster I, this is lowercase and then capital. So I need to just make sure that they're exactly the same. Otherwise, what I'm going to do is not going to work. And you want to make the current ammo and the reserve ammo something reasonable. It's really up to you how you want it to look. This is going to start to change a lot when you program the ability to drop these weapons, because it'll need to be whatever the ammo is at that time. And so I'm just checking to make sure that these three weapons that I'm going to create have got just the standard current ammo and reserve ammo that I've set up on the resource, so that they're exactly the same. But they can really be anything you want. Okay, so now that that's done, we'll need to also just double check physics layers. So if you don't remember, we've got a set of physics layers that we've set up. We've got world, player, object, and weapons. Now, layer 4 for us is going to be where we put the weapons. So I'll come down to collision, object 3D, and I'll select layer 4, and I'll unselect layer 1, and I'll leave 1 masked, and I'll mask 4 as well for good measure. And I'll also mask 3 for objects, just in case you drop a weapon onto an object and you want it to interact. So I'll do the same with all 3 weapons. You could also mask the player as well, like if you wanted to walk through the weapons and you wanted them to move around and interact like that. But in my sort of testing, I found that that wasn't a very nice experience for the player, especially if you're trying to pick up weapons and the collision shape is moving things around. Okay, so now that that's done, we'll come back over to the FPS character and we'll click the little plus button and we'll add an area 3D node to the FPS character. And we'll also need to add a collision shape, but first I'll rename that to pickup detection, and I'll add a collision shape 3D to that. I'm just going to make this a box, and I'm going to make it I'll bring it up to be the same size as the player so that you can't pick things up below the ground. Realistically, this is just going to be something that you decide, what works best for your game. I'm going to make this a little bit wider on both axes, just so that there's plenty of room so that the player doesn't have any problems picking up weapons. Don't have to get too close to them. Okay. All right, so of course we need to also set up the collision on the area. So I'll click the pick up detection node and I'll come to the collision and I'll unselect world and unselect the mask, and we just want to mask layer 4. So that way it'll detect things on layer 4, which is where our weapons will be. I'll connect the signal, so I'll click node and I'll click signal, body entered, and I'll double click on the weapon manager node. Okay, so I'll just remove some space here. And on this, we are going to need to set up a few things. So we know the variable is going to be weapon name. So I'm going to print that out just to show you guys. Make sure that everything we've set up so far is working. Just absolutely make sure that this variable is the same. I'm not adding any kind of checks here, so the assumption is that it definitely exists on the object we're going to detect. It's not the safest, but it will work if we do things properly. I'll jump back over to the main scene that we're working on, and I'll add a new node here, and I'm just going to call it weapons. And I'll drag those 3 spawnable weapons that we created into that node. I'll select them all and just bring them up so that they're inside the sort of play area that I've created here. And I'll just move them apart from each other so that they're on their own. I'll give them a little bit of space so we don't run over 2 at the same time. Now I'll just run this game, and we'll see that as we walk over the top of them, well, actually you can't see because the game's in the way, so I'll just tab out of that. You can see blaster I, and as I walk over these, they print out the name. So just make sure that everything's working up to this point, and everything looks good, nothing's crashing. Okay, so now that we can detect our weapons, we can come back over to the weapon manager and we can start adding some logic here. So First thing I want to do is create a variable called weapon_in_stack. I'm going to make that equal to weapon_stack.find, and I'll just type in there body.weapon_name. What this will do is just first check that we don't already have the weapon in our possession. So this will return a -1 if it's not in the stack. If you guys don't remember what the stack is, it is just a list of weapons that the player currently has in their possession. So if it's not in that, it is going to return a -1, and that will tell us that we need to pick up the weapon. Okay, so the other thing we need to remember is exactly how our state machine works. So we need to eventually call the exit function and pass in a string to the next weapon. Now, the way that these rigid bodies are set up is that they have a string reference to the weapon. So obviously this is fairly early stages. We don't have the ability to drop. We don't have the ability to pick up ammo from weapons on the ground. So we'll call exit, which will just handle everything for us. So let's type if weapon_in_stack is equal to -1, then we need to pick up the weapon. And I'll come down here, and the first thing we need to do is actually add that weapon to our weapon stack. So I'll type weapon_stack.push_front, and I'll push that value, body.weapon_name. Okay, so now that the weapon is in the stack, we're able to switch to it, and we'll also be able to switch back to it if we switch off it. We need to zero out the ammo in the resource. Resources are exclusive. You generally don't have multiple copies of them. So the resources are always there. It's just we're controlling whether or not we have access to them with the weapon stack. And so what we need to do when we pick up a weapon is actually overwrite the ammo and the reserve ammo with the values from the gun on the ground. So that's why the gun on the ground has those values. And so that's what we'll do here. So we'll type weapon list, and we'll do square brackets, and I'll just paste in body.weapon_name because it's a little bit faster, and I'll type .current ammo, and I'll set that equal to the body.current ammo. Okay, I'll just copy that because it's a little bit easier, and I'll paste that down, and I'll just change current ammo to reserve ammo, and I'll do the same thing for body.current ammo. I'll change that to body.reserve ammo with lowercase this time. Okay, so we're going to overwrite those values, and we're going to also emit the signal update weapon stack, and we'll pass in the weapon stack. And then finally, we want to type exit body.weapon_name, and we should be good to go. Last thing we need to do is, of course, delete the rigid body because we've picked it up. Okay, so let's run that and see how we go. So the only weapon that we can pick up is this one on the left here. I'll walk over to it, and it looks like it's picked it up okay. And these ones here obviously don't get picked up because they already exist. And I'm not updating the weapon indicator, which is what controls our position in the array called weapon stack. And so when you pick up a weapon and then you switch, it won't always be the weapon that you're expecting. So if we switch to the second weapon in the stack, we pick it up. The next time we switch, it's going to be there. So you would expect to go back to Blaster N, but you actually ended up on Blaster I think it's called. So we can fix that. We're not going to fully fix it until we start to drop weapons as well. So we've got just a regular int controlling our position in the weapon stack. To be honest, I think this can be improved, and we might do that next episode when we fully fleshed out how this works. So one option that we have is that we can make the weapon indicator 0. So that will always just count up from there. And because that's where we pushed it to the front, it's going to work pretty much off the bat. This is a really simple solution, but it depends on how many weapons you've got in the game. That might be really annoying for the player. So instead what we can do is we can type insert, and we'll need body.weapon_name and a variant, which will just be weapon indicator, and we can delete that. And that's actually around the wrong way, so I'm just going to swap that out. This will be our final solution, weapon stack.insert brackets weapon indicator, comma body.weapon_name. So what we're going to do here is just insert the weapon at the position that we're at in the weapon indicator right now. And that'll sort of, if we're on the second weapon, we're going to put it at the third position, and it just feels a little bit more natural rather than resetting the entire weapon stack. And like I said, we'll fix this up at the end of the drop tutorial, so don't worry too much about this. So I run this just to show you how it looks. So we switch to Blaster N, and you can see now that it shows up in between the two. And so when you switch up, it's Blaster N, and when you switch down is where you expect it to be. So I think this is the best solution. There are currently no limits to how many weapons you can pick up in this game, and we're not going to change that. But yeah, so I think this works best. Definitely comment down below if you've got a better way of doing it, because I sort of wrapped my brain over this for a couple months. And so in our current state, we've got a lot of things up and running and we're almost done, but we can pick up weapons. However, we can't drop them. And you know, in some games you might not want to drop them, but I'm going to show you guys how to do it if you need to. I'm going to add it into this FPS weapon manager just for fun. And we're going to fix up a few things along the way. So the first thing we need to do is add an input. So I'll come up to the project settings and I'll click project settings, and then I'll come across to the input map and I'll type in drop and I'll click add here. And I'm going to make this the letter G. Pretty sure that's a common input. And I'll come to the FPS weapon manager script and I'm going to create a new function right below our pickup function. And I'll just call it drop. And it's going to take a variable and it's just going to be the name of the weapon that we're going to drop, and that's going to be a string. And then I'll just type pass in here, and I'll come right back up to our input function here, and I'll type if event.is action pressed drop, and I'll just call that function drop, and I'll pass in the current weapon dot name. Just make sure to check that variable that is the same as the resource variable weapon name. So I've got this wrong here. I'm going to type weapon underscore name. That's the variable I need to pass in. We haven't looked at the weapon resource in a while, so you might forget that. Just double check it. Yours might be different. In here, the first variable we are going to need is a reference to that in our weapon stack. So I'm going to type var weapon underscore ref equals weapon stack dot find name, comma 0, because we're going to start from the very start of the array. If that returns -1, then this is already a problem and we're not going to process anything, but generally it's going to return something greater than that. So I'll type weapon stack dot pop at weapon ref, which would be the weapon's position in the weapon stack. So what that will effectively do is just remove the weapon from the weapon stack so we can no longer access it. And we're going to emit the signal update weapon stack. You'll have to bear with me. I'm doing it the old-fashioned way here in a lot of these videos. I haven't actually worked out it was updated. I've got a video out on that I put up a few weeks ago if you want to watch. So we'll go on to the next step here. I'll type var weapon dropped. Now, we're actually going to need to spawn a rigid body at this point. But how do we know which rigid body to spawn? We're going to need to add another variable to our weapon resource. So let's pull those up. I'll come over to one of these and you can see we don't have anything. We've got a projectile to load, which is the same thing. It is just a rigid body if you are loading a projectile. So we'll come over to the weapon resource script, wherever you've saved that. And we'll just add another variable here. We'll type at export var, and I'm going to call mine weapon underscore drop, and it's going to be another pack scene. And fortunately, we've already created these in our series when we created them to be able to pick them up. So we can spawn the exact same ones. In fact, we need to, otherwise we won't be able to pick them up. And I'll just drag these into the corresponding weapons, and that's it. I don't know why that has a box on it. Anyway, okay, so we can come back into here, and we've already typed weapon list square brackets name, and so now we can just call that variable that we created dot weapon underscore drop. And then we'll need to call instantiate. So one thing that we need to remember to do is actually transfer the current ammo and the reserve ammo onto this dropped weapon. They have default starting values, but at this point, we're going to want to override them. So I'll type weapon dropped dot current ammo and weapon dropped dot reserve ammo, and we'll just transfer that. So weapon list square brackets name, current ammo, and weapon list square brackets name, reserve ammo. The other thing we need to do before we add it to the scene is actually set up its position. Otherwise, it's just going to spawn at the 0 point of the world. So I'll type weapon drop.set global transform, and I'm going to set that to just be the bullet point, which is like at the end of the muzzle of any weapon. So it's just going to be sort of in front of the player. And I'll just set bullet point.get global transform, and that'll be all we need for that. And now we can add this rigid body to the scene. So I'll get access to the world. So I'll type var world, and I'll go get, and I'll type get tree.get root.get child 0. And that'll just be, in our case, the world node. And so now we type world.addChild and we can pass in weapon dropped. And so now our weapon will actually appear in the world. Okay, so now that we've done that, we can actually switch to that weapon. I think that's probably the best way to go about it. Once you pick up a weapon, you want to switch to it. So we can play the deactivate animation, and we just need to call exit. And I'll just call that on weapon stack 0. I forgot, but if you've remembered, the animation for deactivation actually happens at the exit function, so I don't need to call that in this. So I'll remove that, and I'll just call exit at weapon stack 0. And let's run the game and see how we go. Okay, so I dropped the weapon, I switched to the starting weapon, and it instantly picks it back up. Now, if you're keen-eyed, you might realize that the weapon is falling directly into the pickup detection node that we created in our last episode. So we're going to need to do some things to make sure that doesn't happen. There's a sneaky little bit of code that we can slip in on the rigid body. And I'll just come over to one of them. They all use the same script. So I'll just set up a Boolean variable called pickupReady, and I'll set that to false. And I'll just set up a ready function here, and I'll type await getTree.createTimer, and I'll just make it 2 seconds, and I'll type timeout, and then right below this, I'll type pickupReady is true. And so that'll give us a 2-second window that will allow the weapon to drop to the ground, and it won't activate in the pickup detection. However, we do need to go over to our FPS weapon manager and just make sure that when a body is detected in our weapon manager, that we actually check that its pickup is ready. So I'll come back to that weapon pickup detection function and type if body.pickupReady, and I'll just tab in all of our code. So unless that's true, we're not going to pick up the weapon. And so that should just get us by. And just like that, the weapon falls to the ground and is visible. Okay, so we're cracking along. Now, you might think we're done, but we're pretty far from it. There's a few extra things that we need to do. You could probably think for a little second, with the code that I've written so far, what happens if I try to drop the next weapon? We can drop any weapon that we've got, and we'll go back to weapon in stack 0, which is this pistol here. But what happens if we try to drop that? What's going to happen then? So let's run the game and have a look. Okay, so I've dropped that first weapon, and I try to drop the second weapon. You can't really hear it, but it says invalid get index 0 on array. So there's nothing to drop. So there's a couple of things we need to do to make sure that this continues to roll smoothly. The first thing, which is totally optional, but I think it's good to have, is a variable on our weapon to say that it can even be dropped. So this is a design choice. You don't need to have this. It's just the first thing that I think of when, some games have weapons that can't be dropped, pistols, knives, stuff like that. So I'm going to set up a variable here, can be dropped, on our weapon resource. If you're setting that up, you'll need to tick it on all of the weapons, unless you don't want it to be dropped. So I'm going to leave it unticked on blaster N, so it can't be dropped. And in the drop, I just need to add that to the start of the function, so I can say if. I'll need to get access to it since we only have the weapon string. So if weapon list underscore name dot can be dropped, and then I can just tab in from that. Make it so all of these can be checked. The other thing that I want to do is just make sure that another rule we can also have here is weapon stack dot size is not equal to 1. And so we can't drop our final weapon. That's another option as well. And now all of that won't happen. So now we can't drop. We can drop this first weapon, no problems. But this second weapon, no matter what you do, you can't get rid of it. And so that somewhat solves a problem. The game won't crash, but we'll always go back to that pistol no matter which weapon we have. And there's a couple of other issues, like this one here that you can see where we've picked up the weapon, but it's not showing up. And there's an invalid index on the weapon stack. And you might start to realize that we've got a bit of an issue with this weapon stack, because the way that we're referencing it is not the best practice, and it needs to be fixed. Otherwise, so you can see I've got weapon indicator +1 because I want to be at the next step in our weapon indicator when we pick it up, but we don't have 2 weapons, so there's nowhere for it to go. In that case, so you can remove that. That's probably the first step, but we're still going to have issues. And so I think we can fix this problem altogether. Okay, so let's fix this weapon stack. So we've got to come right back up to the start of the code. This is one of the first things we've written, so don't worry if you don't remember what this all does. I forget sometimes too. So this weapon indicator variable is what controls our weapon stack. When we want to switch weapons, we increment that weapon indicator, which is just an int, and then we feed that to the weapon stack and we pass it into the exit function. So we're essentially just, counting up to a certain point and counting down to a certain point. Which is okay, but then you need to track that position every time you're changing the weapon outside of the weapon change moment. So when you pick up a weapon, when you drop the weapon, and anything else in between, because you never know, you might want to add something in the future and you'll need to update the weapon stack and know where it is. And at least in this particular instance, there's situations where you could add that weapon anywhere in the stack. You don't know where you are. And so we are going to set up a way to do this better, I think. So everything here is going to be aired out, and we can pretty much delete this weapon indicator line here. And I'm going to type var get ref. This is just the variable I decided on. You can call it something different if you want. And I'm going to make that equal to the weapon stack dot find, and I'm going to look for the current weapon name. And so I'll find the current weapon that we have in the stack, and it will return that number. And so now all I need to do is increment that by 1 or reduce it by 1. So we'll say getRef equals min, and it'll just be getRef +1, comma, and we'll just make it can't be any greater than the weapon stack dot size -1. Not dissimilar from the previous code that we had. And we can do the exact same thing for weapon down. I'll copy this variable getRef, and we'll call it up again. And this time, getRef will be equal to the max of getRef -1 or 0. So we can't go past 0, otherwise we will error out. Or we'll actually, to be honest, we won't error out. We end up at the start, which, to be honest, could be something you want to do, but we don't want to do that. I'm not going to do that. So we won't go past 0, and we'll pass that in. And so now we'll be able to get to the next weapon in the stack without having to have another variable to track that, which means we don't need to worry where we are in the stack when we pick up a weapon and when we drop a weapon. Okay, obviously when we pick up a weapon, we were using the weapon indicator, but we can do the exact same thing that we did with the weapon up and weapon down inputs. Here, we can create a variable called getRef, and we can just call up the weapon stack, and we can go find weapon.name. In this case, it's going to be the current weapon. We can call up the weapon stack.find current weapon.weapon name, same as before. I could have copied it. It's the exact same code every time. And so now we're just going to add that, and we're going to insert it at that point. And so now it's just going to increment. It'll be the next weapon in the stack. When you pick up a weapon, if you're in the middle of the stack, it's okay. So that's where it's going to go. And so now we come to drop, and we can do that here as well. We've actually got the weapon ref up here, but I'm going to do it again just because that's what I've decided to do. It could work either way. So I'm going to just type getRef weapon stack current weapon. I'll copy it from where we pick up a weapon because it's the exact same. And then all we need to do is getRef equals max. The exact same as when we drop a weapon is when we go down. So it's essentially the same process. You do it so frequently that you might actually want to set up a function for it. To be honest, it's something that you could seriously consider at that point where it shows up that many times in the code. So it's not the best practice, but it was just something that I thought needed to be done. And it really does solve this problem. So now we can drop any weapon we want. We can pick up any weapon we want. We don't have to worry too much about it. It's going to work every time. Okay, so that I can pick up that weapon, I can drop this weapon, and the weapon stack isn't affected by that, and it just feels really nice. And you can shoot the weapon, that's really cool, I love that. Awesome. We can do a lot of different things with our FPS weapon manager. We can pick up and drop weapons, but right now we are missing a pretty major feature, and that is the ability to pick up the ammo from the weapons and also just pick up ammo from ammo clips and things like that that you might want to put in the world. Realistically, after we do this, you can just attach this ammo script to almost anything and you could be able to pick up ammo from it. So let's get into it. Okay, so let's jump into our FPS weapon manager. We've got a lot going on right now, but we are going to be changing some of the code on our pickup detection. So right now, when we walk over a weapon, we are checking if the weapon can be picked up, and then if it's not in the weapon stack, we add it to the weapon stack and change to that weapon. So these weapons all have ammo. What we can also do is check to see if those weapons, if they are in the stack, to see if we can take the ammo from them. So we'll just need to add an else statement right below this, because we say if weapon stack is -1, which means it's not in the stack, we pick it up. But we can just say else pass, and I'll just write add ammo, and we'll add our function at the bottom of the script. So I'll scroll down to the bottom of the script, and we'll create a function here, and we'll call it add ammo, and it's going to take a weapon reference, which will just be the string, or we'll call that weapon, and it'll also take the ammo. And we'll create a variable here, and we'll just call it _weapon, and we'll make that equal to the weapon list, and we'll use that string reference to get access to the resource. And now we are going to figure out how much ammo we need. We'll call the variable required, and we'll make it equal to weapon.maxammo, and we'll subtract the weapon reserve ammo. So that'll tell us the difference between how much ammo you have and the maximum ammo you can carry, which is how much we need. The next, we will calculate the remaining, which will be the max. So we'll use the function max here, ammo minus required, with it being a minimum of 0. Obviously, we don't want to get into the negatives here. If we are using all the ammo, then remaining is going to be 0. Okay, and then finally, we can say weapon.reserve ammo plus equals to min, and so that we're going to add this to our reserve ammo. Make sure you add that plus before the equals sign. Min ammo or required. So in the case where the required amount of ammo is less than the total ammo that is available to be picked up, we want to only add the required amount. We don't want to add any more than that. I'm just going to come up to the reload function and take the signal that we emit there, and I'll just paste that in, still using that old way. You can watch my video on the new way to do signals in Godot 4. And then finally, we will return remaining. I'm just going to add a return value as an int on this function, just so that we know that if we mess with it in the future, that it definitely needs to return an int for this to work. But that's totally optional in Godot. You don't need to do that. Some people do it on all their functions. I tend to do it on just functions that I know definitely need to return something. And sometimes I forget to. Okay, so after this else statement, where we actually want to do this, add ammo, I'm going to create a variable called remaining again, and I'm going to make it equal to add ammo, brackets, body.weapon name, and the next part, which is the ammo, is going to be the sum of both body.current ammo plus body.reserve ammo. And then I'm going to say if remaining is equal to 0, then we can remove the weapon from the game. So we've picked up all the ammo, it's of no value, just delete it. And then finally, we can say body.current ammo equals to 0, and body.reserve ammo equal to remaining. And so this is the simple way, I guess you could say, to do it. You take all the ammo and you just slap it onto the reserve ammo for the weapon on the ground. This will work pretty well. I'll go into the remote just so we can see the math happening in real time. So let's have a look at Blaster N. So as you can see, I'll walk over and you can instantly see that the reserve ammo is just set to 20. It's not a big deal, but it is something that we might look at changing later on. Okay, so now let's take a look at these reloads here. Things look like they're mathematically working out. We can pick that up. It's got 19 ammo. We can reload it. We can shoot it a bit. We got 10 and we pick up 10. And if we pick that one back up, we only have 10 left. And we can swap them back and forth and we can see that everything is working pretty much as we expected it. I'm not a huge fan of just sending all the ammo back to 0. It's not a big deal, but I think we will change it. But you know, that's it. That's how you add ammo. If that's all you're looking to do, we're done. But there's more that can be done, so stick around. Okay, so let's fix up this current ammo and reserve ammo. It's going to be min remaining. Okay, so we get access to the weapon list body weapon name dot magazine. So it's either going to be whatever's left or the maximum of the magazine, and then we just make the reserve ammo equal to the greater of remaining minus body.current ammo, or 0. And that'll actually do the opposite. We're going to put all of it in current ammo, and the rest will just be sitting in reserve ammo. And personally, I think this is a better design choice, but ultimately these kind of things are really just up to interpretation, how you want your game to feel. I think it's way cooler if you pick up a weapon, you can shoot it straight away. But maybe you want to maybe you feel like it's more realistic if you have to reload it first. You know, there's a bunch of different things. Maybe you try to make a more difficult game, Dark Souls-esque FPS, and you want it to be, you know, so that you have to do a bunch of stuff before you can even use a weapon, like you would have to in real life. You can't just pick up, I mean, sometimes you can pick up a weapon and start shooting. I don't know, I've never shot a gun before. Little fact. Anyway, we're rambling here, so that's done. So let's get into it. Right now, we have the ability to pick up ammo from weapons, but what if we wanted to just have an ammo clip or that's on the ground that we can pick up, or anything like that? Maybe you want to have a box full of ammo, but I'm going to make it on this clip here. I'm going to save a copy of one of these rigid body seats, because we're going to basically just harvest all the code here. So I'm going to save the scene as, and call it blaster n clip at the end, so that it's the clip for the blaster n. And I'm going to probably delete this model and the collision shape, and I'll just add in the clip, and I'll make it local and take away all the nodes and stuff, just so I've got the mesh there. I'll move that to the center of the scene and create a simplified mesh by that little menu in the middle there. And the one thing that we need to add to this script so that it can work with both these clips and the weapons is an export enumerator. And this is going to be a weapon type, and it's either going to be a weapon or it's going to be ammo. And this will be called pickup type, and it's going to be a string, and I'm going to make it equal to weapon. That doesn't need to be a string, so I'll just change that to a string. And so what this will do is it'll make all of our old rigid bodies weapons, and I can change this one to an ammo, and the rest will all stay the same. So this will all work with them. You could create an entirely new script, but I think it's just easier so that we can make it work with everything we've already written. Just sort of just change this script so it can work with both. So we've got this enumerator. We can bring this, this clip into the scene. I'll make a new node here in our world, and I'll call it ammo, just so that we can organize all of it. I'll drag that blaster and clip in, make it a child of that node, and I'll just move this to the back so it's a little bit out of the way. I'll turn it on its side so it looks nice and pretty. And then we just need to change the code a little bit. So let's come down into the pickup detection. And right now we're seeing if the weapon is in stack, but now we also want to make sure that the body that we're walking over is also of type weapon. So we'll go body.pickup type is equal to weapon. We're not even going to check if it's ammo. All right. Which is cool. And I'm going to put a print out there so we can see it as we walk over. Okay, so we need to see that as we walk over a weapon, it still works. and we see the printout weapon. So now we can switch to our blaster N. Let's empty this clip a bit so that we need more ammo, and walk over this, and look at that. We just get 10 straight out of it. Okay, so we're back in our project. So we'll jump over to our FPS character. Now I've already made the animations for these, but I'll show you how they're put together so you guys can get a better idea of how to do this. So it's mostly just playing around with the position and rotation, and what I think works best is that you instantly transition to the striking pose. So 0.2 seconds or 0.1 second even. So you're instantly in that position, and then you linger for like 0.2 seconds. There's a little bit of movement, but there's not a lot. And then you eventually return to that position. And this one does a flip. So you put that all together, it looks like this, where there's that long pause in the melee animation. And I'll show you on a couple of others. Okay, so in the rifle, let's have a look at the melee strike here. We go from this position instantly into this, we linger. There's a little bit of return. I actually think follow through is better than return in this. So I'm not 100% on that one, but you get the idea. You linger, you instantly transition, you have a little bit of lingering, and then you return. So I think that looks really good. We will get to setting up the code for this. I'll just pull the reset on that. Okay, so we'll jump over to the FPS manager, but before we write any code, we need to come to the project settings and we need to add a new action. I'm just going to call it capital M-E-L-E-E. That's how you spell melee. I have to remember. I'm really bad at spelling, so you have to apologize if I get stuff wrong. I'm going to make it the F key, and that will be the key that we use to do a melee strike. So we can come back into the script, and in the input event, we'll need to add a new event. So we can come right below this and we can go if event dot is action pressed and melee. And we can just write pass because we don't have a function to call yet. So I'll come, I want it to be probably after reload. I feel like it reads pretty good then. So write func, and I'll just call it melee again. Doesn't take any variables, it's nice and simple. Okay, and I'll just type pass, and I'll come back up before we forget. And I'll just write here, and I'll call that function if action press melee. Okay, so let's get into writing the melee function. This one's going to be a little bit different from the others because we're going to allow this to interrupt other actions. So we're going to need to refactor a couple of functions, particularly reload, and we're also going to refactor the camera collision and the hit scan damage because we need to modify them to accept this function and use the rate casting functions to detect what's in front of us. But before we write anything in the function, we are going to need to add those animations to our weapon resource. So I'm going to open up the weapon resource, which is right here. I'm going to add the animation to the animation variables, which is this top set here. So I'm going to type at export var melee anim, and it's going to be a string. And the other thing that we want to do is under damage, we're going to also add export var melee, can't spell, underscore damage. And so that will be the damage it does. Okay, so in the weapon manager, we're just going to come into each of these, and the naming conventions are the same. So we can go blaster I melee, blaster D melee, spell it right. Hit save. I've forgotten to do the damage, so I'll do that for both of those. I'm going to make it the same as just one. We'll do for now. We'll go blaster N melee and melee damage 1. Okay, and I might change that to be if you guys. This one's all messed up. That's okay. We'll just leave it as is. Okay. So now we've got the animations, we can start writing that function. So we can come back up in here and we're going to allow this one to interrupt other functions. So we need to write a different line that we normally start with. So normally we're checking to make sure that the animation player isn't even running. But in this case, we only want to make sure that the current animation isn't already the melee animation. So we can't interrupt a melee hit, but we can interrupt pretty much everything else. And if that's a problem, we can always change that later. Animation player dot get current animation, and we're going to make sure that it's not equal to current weapon dot melee underscore anim. So just make sure that this variable name is the same as the variable name in your weapon resource. Okay, and underneath this, we are going to say animation player dot play, and it's going to be the current weapon dot melee anim. So if you want, you can just copy this and paste it in there. Okay, so let's first make sure that this is running the way that we expect it to. So we can see that. We can shoot and it will just instantly play. One thing that you'll notice straight away is that we can basically shorten our reload time by interrupting the reload. We're going to fix that in a second. But other than that, it's working how we expected it to. So let's fix that reload thing before we go any further. So the reload is right above us. Now, what we're doing with the reload is we're essentially, we're checking if there's not an animation playing, and then we're just reloading instantly before the animation is finished. So we can just probably copy this variable. We can come up to the on animation finished signal that is being triggered by animation player, and we can add another check here. We can say if anim underscore name is equal to current weapon dot reload anim, and then we'll just put a pass there because I haven't written the function. We're going to move or refactor this part of the code to be a new function, and so we'll call that function down here. We'll call it calculate underscore reload, and we'll essentially just copy all of this and we'll paste it there. And I'll just remove some of those indentations. You can press Shift Tab to do that. And then where this all is, we can delete that and call, actually we don't even need to call the function, we just delete it all. Okay, and then we will call that function when the animation is finished, not as soon as we press the button. And so that will prevent us from being able to interrupt the reload. So we'll run that again. I'll just reduce some ammo. And now, until I let that finish, doesn't matter what I do, I have to let it run. Maybe you don't want the melee animation to be able to interrupt the reload. It's really up to you if you want to do it this way, or if you want to just make it so the melee can't interrupt the reload. Your call. Otherwise, let's continue. So what we need to do right now is we need to do a raycast from our melee strike to the object in front of us to see if it can be damaged. We've got a function which is right below this called get camera collision that we're going to need to refactor a little bit in order to work with melee and also work with our hitscan weapons and also work with our weapons. So right now the range is just currently being called in the get camera collision function. What we want to do is probably just cut that out and replace it with another variable. We'll just call it underscore weapon underscore range, all lowercase, and we'll just put that in the function here, weapon underscore range. And now it'll also error out at the shoot location because that's where we need to be supplying that variable now. So we can paste that back in, current weapon dot weapon range. And now when we do our melee strike, we can also use that function and use a shorter range. So I'm going to go back to the weapon resource and I am going to add that variable, and I'm also going to add the melee damage as well. So under weapon range, I'm going to create another variable. I'm going to call it expert var melee single L range. I'm going to make it a float. this time, and I'm also going to make it equal to like 1.5 as a default value because like that's generally good enough. If you want it to be longer, perhaps for like a bigger weapon or something, you can increase it. And the export var, and we'll call this melee underscore damage. And this can be an int, and I won't give this a default value. We'll need to come back to our weapons, and we'll just see they've got the weapon melee range, and I'll just make this 1. Perhaps I could have given it a default value of 1. Okay, so now we come back there, we can actually write our function here. We can come in and we can go var camera collision is equal to get camera collision, and we'll call current weapon dot melee underscore range. So now that we can do that, we still need to change our camera collision a little bit further. As you can see right now, we're just returning the position of that intersection, which is not quite what we want. That position is important, but we also want to know what the actual object is that we collided with. Now we're doing this again in Hitscan collision, but we don't want to use that function because it's using the bullet point, which is not something that we want to use in the melee section. So we just need the object. We've got it already. It's actually being returned from this function here in the get camera collision. So what we actually want to change this to is to return an array of both the intersection object and its position. So what I'm going to do is I'm going to change this to be an array. So var collision is actually going to be an array. We'll go square brackets, and it's going to be the collider. I'll put that first. Intersection.collider and intersection.position. Okay, so now we're returning that. It's not happy. I need a comma. Don't forget the comma. Okay, so now we are returning 2 objects. For the array end, we're going to need to return a null at the start because we still need to return an array. We don't want to confuse ourselves. And I'm going to change this to an array as the return object. And then in the shoot, we're going to need to change things here. Rather than sending the camera collision, we just need to send the position like before. So that's the second object in the array. That's number 1. And same with this. It just needs the camera collision position. Run a little test to see if that works. Everything is functioning as normal. That's what we want. Still doing damage, everything like that. So that is positive. Just make sure everything's working when you do these refactors. So this now returns an object, and we can type if camera collision square brackets 0. And now we can calculate the direction. So we can type var direction is equal to, we'll do double brackets here, camera collision, and this will just be the position. So square brackets 1 minus, and I'm going to call the owner dot global transform underscore transform dot origin. The reason for that is just for whatever reason, I found that that was working better than using the weapon manager as the object for the global transform dot origin. And we'll just type dot normalized. So that's our direction. And then we can just pass in Hitscan damage. Now we're going to need to refactor that because that takes a collider, a direction, and a position. So we know what the collider is. We can call camera collision square brackets 0. The direction is the variable we just created, and the position is camera collision 1. But We have another problem here. Hitscan damage is using the current weapon.damage. We want to replace that with another variable. We'll type weapon underscore weapon underscore damage. And it's going to get upset, so we'll type that up here. It should be happy, and we'll see this have an issue here. And so all we need to do to fix this is just call current weapon dot damage. Once again, just making sure the variable name is the same. And then up here for melee, we can call current weapon dot melee damage. Dot melee damage. That's not a function. Close brackets. Okay, and so now we've separated the damage from hitscan damage. We can call that in a separate location, like in the melee function. And so now we can apply the melee damage when we detect a hit. And so if we run the game now, we just test that out, make sure it's working. It looks like it is. Now we can run over to this box. It's always a good indicator of whether or not things are working. We can come here and we've got a little bit of an error. What have we got? Index, I made a spelling mistake. It's a very common error of mine. Origin. Let's try that again. Just walk straight over to the box this time and you can see it's working properly. Sorry about that error. And so now things look great. We have got it interacting. We can walk over to one of these targets to confirm that it's working. And so now we've got melee damage. How cool is that? And everything seems to be working as normal. One major flaw of the way I'm doing things here that I've thought about a lot and eventually decided this was the better way to go, mostly just for the purposes of what we're doing here, is that we are just using a raycast for this. So if I'm this much off, it's not going to detect a hit because I'm raycasting to the center of the screen, which might not feel very good to the player. So just feel that out, and if you're not happy with it, you probably need to replace it with an area 2D around a wider range, or you need to cast more rays. So there's a couple of options there, but right now, this is what we're going to do just for like an easy one. My assumption is, my reasoning for doing that this way is that because I'm assuming if you're performing a melee attack, chances are the object you're trying to hit is very close to the screen. So it's highly likely that it's going to be covering the center of the screen. Obviously, that's not always the case, and so there's going to be a couple of mishits when you're not quite there, and if you're out of range just a little bit. So that's obviously a range problem, and this is like the problem with the raycast being just from the center. So maybe you need to do more raycast. If you find that's a problem, let me know. I can probably do an updated video where we add an area 3D to detect what's in front of us instead. Or we can refactor the get camera collision to perform more raycasts if we want. That's an option too. But other than that, that's how you do it.
We are going to be finally adding a control rig to this FPS manager. I'm going to be doing this with a rig, but it's mostly for demonstration purposes. It's incredibly simple to do, and it's easy to add at any time in your project. So I recommend that you think about adding a control rig when you're further along in your project, but I'm going to show you now so that you have this for reference, or you can follow along as well. Because the entire point of this weapon manager is to make sure that when you get to this stage of your project, you can add a rig without changing anything, or without needing to update animation references that have been baked into your code.
And the first thing we're going to do is just open up the FPS character scene. First thing we should really do is just save this scene as a separate one. So I'm going to save it as FPS character with rig, and I'm also going to update the kinematic body node's name. And then finally, we're going to delete the FPS rig that we have currently. And I'm also going to remove all the resources and the starting weapons just so that we're back to a base 0. If you had nothing, and we're going to start from scratch. I've got a rig that I created last year. It's not perfect. As you can see, when I open it up, it's still a full body. We're going to have to deal with that. I'll make this available for download, but it's not really finished, so keep that in mind. So the first thing I'm going to do is just drag this into my scene here. And I will drag it just into the root scene so that it doesn't get too much transforms put on it. I'm just going to reset the transform, and then I'm going to drag it as a child of the FPS rig. I'm going to make it local. I didn't properly prepare this rig, so it's got a lot of control nodes. And I'm just going to remove those because we don't need them. That's from Blender. The other thing is I've separated out the mesh so that we can remove everything except the arms, because that's all we need from this mesh. So I'm just going to go and I'm going to select all these other meshes that we don't need, and I'm going to move them. So if you've got your own rig, you won't need to do this. All right, so with everything left over, we've got this. We can start to work on actually positioning this rig. So you want to click on the camera and click preview. I'm going to come back down to our rig, and I'm going to just lower it a bit so that it sits a bit better in the frame. I'm going to check another animation just to see how it looks with the pistol. I think it's a little bit too low, so I'm going to bring it up a little bit. And also the rifle. And I think I'm happy with its position. So once I'm happy with that, I can move on to the next stage. And we'll need to connect the animation player to the weapon manager. So we've got an onReady var animation player here. I want to make this a little bit easier for your future rigs that you want to put in or any other work that you want to do. So I'm just going to remove that line, and we're going to create a new variable with the exact same name, but it's going to be an export variable, and we're going to make it equal to an animation player. And so now you can just drag and drop whatever animation player you want. Okay, so now that that's done, we can drag that over into the animation player under the weapon manager. So the next thing that we need to do after that is we need to set up the resources for the 3 weapons that we have. We've got a rifle, we've got a pistol, and we've got an AK-47. So I'm just going to come down to where I've got my weapon resources. You can see my file manager is a bit of a mess, so we're not going to worry about that. I'm going to create a new folder and just call it something like rig weapon resources. Okay, and I'm going to create a new resource, and I'm going to create a weapon resource. And I'm just going to name this first one 1, and then I'm going to duplicate that and rename. Actually, I'll call this AK-47 because I know the names of these resources already. I'll create another one, I'll call it pistol. And the one that I called 1, I'll just rename to rifle. Okay, cool. Awesome, so let's go through and set these up. We need to make sure that these animations match exactly the variables in the weapon resource. So we'll come back up, the weapon name, we're just going to call it rifle for the rifle, and all these animations. So they're rifle underscore activate for me, and it's all pretty consistent with the variable naming. So I'm just going to go through. So for the animations you want to play, just make sure that they're the same as the animation in the animation player. I'm going to go through and add some ammo here. It's pretty basic stuff, 30, 60, it's going to be an auto fire, it's going to have a 2000 range, damage of 1, and it's going to be hit scan. I don't have a weapon to drop yet, so I'm going to leave can be dropped unchecked for now. Okay, I'm going to head to the next weapon. It's going to be a pistol. This might take you a little bit longer if you don't know the names of your animations. I'm pretty familiar with this rig, so I'm just going to go through and name these. I don't have an out of ammo animation for all of these. I'm going to leave it blank. It's not advisable to not to leave an animation blank for this weapon rig. The behavior won't be as expected. So if you do have like a placeholder animation, that's helpful too. I don't, so we're just going to roll with that. Okay, last one is AK-47. Copy that down and just name all these animations as well. And we'll give them some ammo and reserve ammo to start with. Make it auto fire. 2000 range, probably a bit long for an AK-47, but we'll roll with it. Hit scan, and then we can go next. Now, we need to come back up to the weapon manager and add these resources to the weapon manager. So under the size, we can create 3 new resources, and we can drag and drop these resources into this array. And for the start weapon, I'll make all 3 starting weapons. And so I'll just type their names in here: pistol, rifle, and AK-47. All right, so things should work as normal. I just want to show you here, we'll run it just to make it sure it starts and there's no problems. We'll delete that FPS controller and we'll drag in the new one. Okay, so let's run the game and make sure things are working so far. It looks okay. We can spawn in and we can shoot, and it looks like the hit scans are working and doing damage to the box, but we can't change weapons yet, and that's because we haven't set up the signal. I want to introduce a new way to connect that signal, because if you're changing the rig often, if you're prototyping, you're going to be setting up that connection quite frequently. So I'm going to come down to the on animation player animation finished, and I'm just going to rename that function to make it a little bit shorter. I'm going to call it on animation finished, and I'm going to copy that function name, and I'm going to come up to the ready function, and I'm going to type animation player dot animation finished, and then I'm going to say dot connect, and then I'm going to paste that callable in on animation finished, and now that signal will be connected up at runtime, and we should be able to switch weapons here, no problems, and automatic firing will work as expected. You can see the rifle is a bit of a laser. Okay, cool, so we're rolling, things are looking pretty good. We're not quite done yet though, because we need to add the ability to drop weapons and pick up weapons. So we're going to need to create a couple of rigid bodies for the weapon drop. I'm going to create a new scene with a rigid body, and I'm going to drag those models in that I've got for these weapons. So the first one is the pistol. I'll make local and remove the parent node, so I've just got the mesh, and I'll click the mesh and click this button that says mesh and create a simplified Trimex collision body. I'll rename this rigid body to pistol, and we will drag that script in. I'm having a bit of trouble finding it, so maybe if you know what it is, just type weapon pickup. The weapon name will be pistol. Current ammo will be 9, the reserve ammo will be 9. These can be any values you want. These are just what I'm picking, and the pickup type is obviously weapon. Okay, so we can save that scene. I'm going to create a new folder under the FPS arms folder, and I'm going to save that there. Cool, okay, so we need to create 2 more of these for the rifle and the AK-47. So I drag that rifle in. You can see the rifle is gigantic because I haven't treated it yet. Do the same as before. I'll drag that model in. I'll remove the parent node. So I've just got the mesh, and I will change the scale of this. And once again, I'll click that mesh button and click create simplified collision vertex. And I'll do the next one as well while I'm at it. I'll drag in the AK-47, make it local, create a simplified collision convex mesh, and change this to AK-47. And also make sure to rename the nodes. Okay, so I'll type weapon pickup and drag that script into the rigid body, and I'll name it rifle 3030, that's fine. We save that, and then same with the AK-47. I'll drag that script on, I'll call it AK-47, I'll just give it 20 current, 20 reserve, and obviously it's a pickup type weapon again. So we'll save that as well. And so now we can come back to the FPS weapon manager, and in those resources, we can add those rigid bodies as the weapon to spawn on drop. Okay, so we'll drag it for the pistol. Make sure you get the right one, not a projectile load. And also remember, as you're doing this, to make sure that you check can be dropped so that you can actually drop the weapon. And for the AK-47, I'll do the same. I'll drop that onto weapon drop and check can be dropped. Okay, so we should be able to drop these. Don't forget as well to set up the collision layer. So right now, the default is obviously the world. These need to be set up as layer 4 in our project for weapons, and they need to mask the world. All right, so I forgot that on the pistol. I'll come back over, and I'll do that for the AK-47 as well. 4 and 1 as the mask, and we should be able to run the game. So now we've done that, we can drop the weapon, we can pick up the weapon, and things are looking pretty good. Okay, so the next bit of fine-tuning that we need to do is the bullet point, which we set up as the place to do a raycast for the hit scan weapons and also to spawn the weapons. So you would have noticed that those weapons sort of like came out of the face of the camera because that's where the bullet point is right now. So I'm going to add that animation to the animation player. You will see a warning that says that changes to the imported tracks will not be saved. That pretty much means what it says on the tin. You can't make changes to the imported tracks, but you can add tracks to things that weren't imported. So we can add this bullet point to these animations and it should just work perfectly. So don't worry too much about that error. I'm just going to come in and move that bullet point to the front of each weapon. and key that in. Can be a little bit tedious working in 3D space, so I recommend using the perspective shifter, just keyboards 1, 3, and 7. Okay, so now that's there, I can come back. I always like to key it to 0, 0 on the reset so that it sort of goes back to 0 in the case of not having a weapon, or better just be in the center. Okay, so I'll do that for the pistol. I'll come down to the rifle and I'll also key it in there, make sure it's in the right position. Doesn't have to be perfect, as long as it's in a general spot that is going to make sense for the player. Last thing you want to do is make the raycast go from a place where you're not expecting it to and ruin the player experience. Okay, so now when we drop the weapon, it should drop out in front of them and our raycast will be a lot more efficient, or a lot more accurate, I should say. Okay, that's great. So let's add those rigid bodies to the scene as well so that we can pick them up. We'll come into the world. I've got the weapon node already. I'm going to drag all 3 of those rigid bodies into the world, and I'm just going to move these around in this scene so that they're positioned, just to make sure. We're going to test out that these are working normally. Okay, so let's run the game here. You can see the rifle is a little bit smaller than the AK-47. We'll have to work on that. We can shoot. Okay, we reduce the ammo down here. I'm going to empty all my ammo here, and I'm going to walk over that rifle to make sure that it works as expected. So it's got 60, I believe, and I pick up 60 no problems.
Okay guys, that's all for now. We have finally created a full FPS manager. Massive props if you made it all the way to the end of this video. All that's left now is the juice, which I'll be covering in the next few months. If you found this helpful, then I certainly appreciate a like and subscribe. If you want to support me further, you can do so on the Patreon, where you'll get access to early videos and any other goodies that I put out, like assets and courses. Anyway, that's all for this part 1. I'm taking a bit of a break and I will return with part 2 soon. I'm Isaac from Chaff Games, and I'll see you next time.